Hello students and welcome to this lovely platform of PhysicsWallah English. This is the Champion series. My name is Shivam Bhargava and I welcome all of you to lecture number 15 in which we are going to start with functions. Now all of you might not know me. You have seen me on this channel for the very first time. So I take mathematics in PhysicsWallah for more than an year and I have been teaching batches in which Hindi and English both are allowed. So in case I start speaking a little bit of Hindi in between, I'll quickly realize it. But please bear with me some of the Hindi words, okay? It might not be entirely possible for me. In between there might be 2 or 3 instances when I might speak up Hindi. But I'll try to get back to English, okay? I'll realize it sooner or later. So functions is a chapter in which we have to be very, very attentive, very, very careful. The good thing is that you have already studied sets and relations from Aman sir. He's not well. He might be back soon. Wish for his good health. So we are going to start with functions, and functions is one chapter which is the starting of your differential calculus, a very big unit in which you are going to study functions, limits, continuity differentiability, differentiation and application of derivatives. So all these chapters, the base that gets formed is in functions, right? So you have to be very, very attentive, very, very, now I don't know the English word for this, aware, okay. So very aware of all the things that are happening in front of you, right? So let's start with functions. First of all, we'll define what is a function, definition of a function. So you have studied sets, you have studied relations, and in relations you studied about 2 sets A and B, and don't say that you didn't study. I have seen that entire lecture. I have seen what all things Aman sir has taught you. You have definitely studied this. So when you define a relation from A to B, the elements of A, A1, A2, A3 and so on till let's suppose AM. There are M elements in set A and there are N elements in set B. Right? There are N elements in set B and there are M elements in set A. Now, the relation, when we define it, there is no such condition. A1 can be linked to any of B1, B2, B3 or Bn. A2 can be linked to any one of B1, B2, B3 till Bn, and it can be linked to more than one elements as well. Like A2 can be linked to B1, B2, B3, all 3 of them, no problem. But when it comes to function, function is defined as those relations in which, I generally say ध्यान से सुनिएगा, I'll say listen carefully, those relations in which each and every element of the domain, has a unique image in the codomain. This is the definition of a function. A relation in which each and every element of the domain has a unique image in the codomain. You know that if I map A1 to B1, right? If I map A1 to B1, B1 is the image of A1, right? Yahan pe, in this case, you can write B1 is the image of A1, or you can also write A1 is the pre-image of B1. You use these 2 terms, image and pre-image. So when you map A1 to B1, under the condition of f, this is a function f from a to b, a1 is mapped to b1. It says that function, for a function to exist, it says that each and every element of the domain must have a unique image in the codomain. None of the elements a1, a2, a3 till am should be without an image. None of the elements. Every element should have an image, and no element of the domain can have two images, two or more images. They all have to have one image. Yes, more than one element of the domain can have the same image in the codomain. That is not a problem. See, a1 is linked to b1. A2 can also be linked to b1. That is not a problem. But the problem is when b2 is, no, in fact, when a2 has two images. The problem lies when a2 is linked to b1 and b3. Now there is a problem because now the image is not unique. There are two images of a2 and that is not allowed. Right? So for a function to be defined, each and every element of the domain must have a unique image in the codomain. Now there is an example which I give to students generally. They find it amusing. Okay? Oh, right? So they find it amusing. I hope it makes learning easier. I have no such thoughts in my head, but this is just a way of making you people understand. Let's suppose A is a set of boys, and B is a set of girls. Right? Disclaimer, I have nothing in sync with the thoughts behind this explanation, but just to make learning easier. So A is a set of boys and B is a set of girls. As I am a boy, I feel like suppose there is B1, B2, B3 and so on till Bm. Here we have G1, G2, G3 and Gn. We as boys want that this community, like the group of our friends, must have at least one crush. One crush. Crush is basically a girl that we like. Right? So B1, B2, B3 till Bm, all of us must have a crush. But among the association, if a boy has two crushes, then he will be crushed. Right? It should not be that a boy has a crush on two girls. A boy can have a crush on maximum one girl only. Right? There is no problem in 2 or 3 boys having a same crush. Right? There is no problem in that. So B1 can be linked to G1, B2 can be linked to G2, B3 can also be linked to G2. Similarly, Bm can be linked to Gn, let's suppose. Right? Now there can be a girl who says, I don't want to be the crush of anyone. I don't want to be that one. So a girl can remain without a pre-image. Right? A girl can remain without a crush, but we boys, we want every one of the boy must have a crush. So this explains the condition of a function. Similarly, function has that each and every element of the domain must have an image in the codomain, but an element of the codomain can be without a pre-image. Right? Here B3 can remain without a pre-image. Here G3 can remain without a crush. Right? G3 can be that one girl who no boys has a crush on. So this explains the concept of functions through mapping. Right? We learned that each and every element of the domain, must have a unique image in the codomain. Also, to determine whether the given graph is of a function or not, we use the vertical line test. we use the vertical line test. Vertical line test. What is a vertical line test? Let's suppose this is your x-axis. This is your x-axis, and you draw a graph. You draw a graph. You have to determine whether this is a graph of a function or not, right? What you will do is you will draw infinite vertical lines. You will draw infinite vertical lines. Infinite vertical lines means even if there is a slight possibility, of any vertical line cutting the graph at more than one point. If any vertical line intersects the graph at more than one point, it is not a function. It is not a function. If any vertical line out of the infinite lines, if any vertical line intersects the graph at more than one point, it is not the graph of a function. The explanation is very simple. Let's suppose you have a graph like this, and you draw vertical lines, and this vertical line cuts the graph at 3 points, right? This vertical line cuts the graph at 3 points. Now what happens is, when you draw vertical lines, you fix x coordinate. You say that this line is x is equal to x1. And now corresponding to x1, you are getting 3 values of y. Corresponding to x1, you are getting 3 values of y. So that means one element of the domain has 3 images in the codomain. This cannot be a function. You knew that it has to be a unique image in the codomain. In this case, every vertical line will cut the graph at only a single point. That means x1 is linked to only one of y1, right? Or any one of the y's. So x1 is linked to y1, x2 is linked to y2, and so on. I hope you people are getting me. I wish I could get a response from you, but at the end of the lecture, I will. Do comment in the comment section. Like if any of the slides, if any of the heading is not clear, you can mention it in these comments below. And if something is very clear, you can write, like let's suppose you are clear with vertical line test, you can write vertical line test OP. That can also be written in the chat. Chat is not only for the negative comments, it is also for the positivity that can be spread around, right? So vertical line test, if any of the vertical lines intersect the graph at more than one point, it cannot be the graph of a function. So you might have come across a lot of graphs, a lot of functions around you till date. A few of them, I'm just mentioning a few of them because we are in a situation when we have to deal with problems or we have to deal with questions that can come in your exam. All these things that I'm going to tell you on this screen is just for gaining the knowledge that should have been in class 11th. Now you are in your end phase of class 12th. These things might not come as questions, but they are good concept builders. I hope by now your concept is strong, but all you need is a bit of a summary thing, right? So first, functions, common functions. Functions we commonly come across. So first is modulus. Second is logarithm. like we can write y is equal to mod x over here. We can write y is equal to log x base a over here. Third will be exponential. Exponential. This is y is equal to a to the power x. Fourth can be greatest integer. Y is equal to greatest integer of x. Fifth is fractional part. This is y is equal to fractional part of x. Apart from these, you come across trigonometric functions. Trigonometric functions you are all aware of: sine, cos, tan, cosec, cot and sec. Then you come across inverse trigonometric functions, that are sine inverse, cos inverse, tan inverse, cot inverse, cosec inverse and sec inverse, right? You come across all these functions on a daily basis. What we are going to study about them is in form of questions only. So whenever any of these functions come in your questions to follow, I will discuss the concept involved in that and I'll discuss the property as well, right? But all these functions, you know that you have studied it in one of the lectures or more. You have not been listening to this for the very first time, right? So y is equal to mod x, y is equal to log x base a, y is equal to a to the power x, greatest integer function, fractional part of x. All these functions have a specified domain and specified range about which we are going to study in a while. Right? We are going to study about the domains and range of these functions. Right? Apart from these, what I told you, these are trigonometric functions. Trigonometric functions. Then you have inverse trigonometric functions. Then you have algebraic functions. Obviously, you have algebraic functions as well. You have linear, you have quadratic, you have cubic. All these are functions. Algebraic functions. Like let's suppose you can write over here y is equal to x square, y is equal to x cube, y is equal to ax square plus bx plus c and so on. Right? You can write linear, you can write quadratic, you can write cubic and so on. All these are algebraic functions. Then there are rational functions as well. Rational functions. Rational functions are those in which you have a polynomial in the numerator and polynomial in the denominator. Like let's suppose y is equal to 1 upon x minus 2. Or y is equal to x minus 1 upon x minus 3. Or you can also write a linear divided by a quadratic. All these expressions give you rational functions, rational expressions, and all these are functions as well in obviously their respective domains. जो domains we define, in those domains these are functions, right? So these are the functions that you come across. Do write a note on this. Mention this in your notes so that you are aware of all the things around you. Doesn't make sense, but yeah, do write them. Okay? I hope you might be thinking that yeah, we know these things. Please move on. I am moving on. Let's move on to the domain of a function. Domain of a function. So what do you mean by domain? We say that function is a machine in which we get an input, the machine processes it and gives us an output. So what comes in is your domain. What comes in is your domain. This is fx, let's suppose. What comes in is your domain. What goes out is your range. Right? The output is your range, the input is your domain. Now, sir, you told us about a word codomain. What do you mean by codomain? You must have studied it in relations. Codomain is the list of all the possible outcomes. Codomain is the list of all possible outcomes. All possible outcomes. And range is basically the actual outcomes. Actual outcomes. Right? So range will always be a subset of codomain. This is a thing that you need to know. You must be knowing this when you studied relations. Codomain is the list of all possible outcomes and range is a subset of codomain. Now this domain, how do we find this domain? There are certain rules in mathematics. There are certain laws that have to be followed. First of them being that if you write anything under the root, this anything must be greater than or equal to 0. This anything must be greater than or equal to 0. Second, if you write anything in the denominator, this anything should not be equal to 0. Denominator should not be equal to 0 and anything under the root should be greater than or equal to 0. Are these the only two rules that we have to follow? Kind of. Because every other function will have its specified domain and you must have studied about wavy curve. We can find out the domain of expressions using inequalities. Right? So what are the other common domains of the functions that we know? Please have a look. Domains of functions. Domains of functions. Like first was y is equal to what did we write? Modulus. Y is equal to mod x. Here x will belong to all real numbers. Mod x can have values from minus infinity to plus infinity in place of x. Right? X has no boundation. It is not that it has to be greater than or equal to 0. Y actually is greater than or equal to 0. X can be any value from minus infinity to plus infinity. So x belongs to R for y is equal to mod x. Second, y is equal to log x base a. When we write y is equal to log x base a, we need to specify that x has to be greater than 0, x cannot be negative, a has to be greater than 0 and a cannot be equal to 1. You have to remember this. And in place of x, if there is fx, then fx has to be greater than 0. So we deal with that inequality part and find out the values of x which satisfy the expression. Like let's suppose if I write y is equal to log x square minus 1 base x. Now x is a variable, right? So x square minus 1 must be greater than 0 and x must be greater than 0, x cannot be equal to 1. These three conditions correspondingly, like simultaneously, will give me the values of x which we can put in this expression. Right? So whatever is written in place of a, it has to be greater than 0, not equal to 1, and whatever is written in place of x has to be greater than 0. Defined domain of log. Right? Then the third function that we wrote was exponential. Y is equal to a to the power x. Here a has to be greater than 0 and x belongs to R. A has to be greater than 0. The base cannot be negative and x can be R. Right? Then the fourth function that we wrote was greatest integer. Y is equal to greatest integer of x. Again, this has domain x belonging to R. X belonging to R. And similarly, y is equal to fractional part of x also has domain x belonging to R. You can put any value of x in place of greatest integer of x and fractional part of x. You can put any value of x. There is no restriction as such. Right? Then when it comes to trigonometric functions, we write y is equal to, let's suppose, sin x or cos x. Y is equal to sin x or cos x. Here x belongs to R. You can put any angle, any value of x in place of x in sin x or cos x. There is no restriction. But when it comes to tan x, when it comes to y is equal to tan x, here x belongs to all real numbers except for 2n plus 1 pi by 2, where n belongs to integers. That means you cannot put x as odd multiples of pi by 2 in place of x. You cannot put x as odd multiples of pi by 2. Right? Since we define tan x as perpendicular upon base, base becomes 0 at these angles. So we don't include these angles in the domain. Similarly, if you talk about cot x, so tan x and sec x have the same domain. Tan x and sec x have the same domain. Cot x and cosec x have the same domain, and that is x belongs to R except for odd, or in fact multiples of pi. Multiples of pi cannot be put in place of x for cot x or cosec x, because at these points p becomes 0, the perpendicular becomes 0, and we cannot have 0 in the denominator. So x belongs to R except for n pi, where n again belongs to integers. Obviously integral multiples of pi. They should not be included in the domain. Right? When we talk about inverse trigonometric functions, beta, when we talk about inverse trigonometric functions, again, the domain will be studied in depth when we study ITF, but till now, the things that we can know about it is its domain. Like let's suppose y is equal to, you write sine inverse x or you write cos inverse x. So the domain will be x belonging to -1 to 1. Then if you write tan inverse x or cot inverse x, here x belongs to R. X belongs to R. Similarly, if you write cosec inverse x or sec inverse x, it becomes -infinity to -1 union 1 to infinity. Or you also write it as R except for -1 to 1. In a lot of books, you will see the domain written like this: R except for -1 to 1. Right? So these are the domains of commonly used expressions that we'll come across. Apart from these, when questions will come, I'll explain you how did we find, how did we get to the domain of this. You must be aware of these few domains of these functions, right? These are the basic ones. Next, range is a very important topic. Range is a very important topic. And then again, all these functions that you studied so far, like let's suppose if I have to write the ranges as well, so here y will belong to 0 to infinity. Mod x also always gives me a non-negative quantity, either 0 or a value greater than 0. So the range will be y belonging to 0 to infinity, the actual outputs that come, right? Then y is equal to log x base a. Here y belongs to -infinity to infinity. X will take values greater than 0, but y can take values from -infinity to infinity. There is no as such interval in which y is not defined. Y is equal to a to the power x. When you write this as a greater than 0 and x belongs to R, y is always greater than 0. Y is always greater than 0. And you can see that here the domain and range get interchanged, since these two are the inverse functions of each other. These two are the inverse functions of each other. You will come across this term later on today in this chapter. But since these two are the inverse of each other, the domain of this function becomes its range and range becomes the domain, right? So y is greater than 0 for a raised to the power x. Then y is equal to greatest integer function. Here y belongs to integers. Y belongs to integers. It will take only the integral values, no other value it will take. Fractional part, when you talk about fractional part, y belongs to 0 to 1. When you talk about the fractional part, it can only take values in between 0 and 1. It can be equal to 0, but it cannot be equal to 1. Then sin x, cos x, y belongs to minus 1 to 1. Y is equal to tan x. This has y belongs to R. Cot x, again y belongs to R. Sec x and cosec x. Sec x and cosec x, it will be y belonging to R except for minus 1 to 1. Sec x and cosec x will have y belonging to R except for minus 1 to 1. Again, these are the functions. The next page will see the inverse trigonometric functions. So again, the domains here will become the range, not all. No, this statement, I take back this statement. The domain here will be restricted when it comes to the range over there. But you see this, y belongs to minus 1 to 1. Then here x belongs to minus 1 to 1. Tan x and cot x, y belongs to R. So the domain becomes x belongs to R. Cosec inverse x and sec inverse x, the domain is minus infinity to minus 1 union 1 to infinity. There the range becomes minus infinity to minus 1 union 1 to infinity. Here if you talk about ranges, y belongs to sin inverse x minus pi by 2 to pi by 2. This is not the same as R, which you expected. This will get reversed, but it is only a part of R, right? Why it happens, we'll discuss it when we'll discuss inverse. And in fact, inverse trigonometric functions. You'll discuss that in detail over there. Cos inverse x, this has range, y belongs to 0 to pi. Tan inverse x, y belongs to minus pi by 2 to pi by 2. Cot inverse x, y belongs to 0 to pi. Cosec inverse x, y belongs to minus pi by 2 to pi by 2 except for 0. Sec inverse x, y belongs to 0 to pi except for pi by 2. These are the ranges of various inverse trigonometric functions and the normal functions that you come across. How do we find the range of polynomial or algebraic expressions? We'll see in a while. But these are the common noted ranges and domains of these functions. How do we find range of a function? So there are, I guess, 5 or 6 methods, out of which the first method is common sense. Common sense plays a very key role, and common sense is not that common in common people. So you have to be above the level of common people and you have to have this common sense. Very important. Find the range of y is equal to minus 3 plus mod of x minus 1. Y is equal to minus 3 plus mod of x minus 1. Common sense says that mod x minus 1, this has to be a value greater than equal to 0. That means you are always adding something to minus 3. So what will be the minimum value of y? What will be the minimum value of y? It will be minus 3. Y minimum will be equal to minus 3 because you are always adding something or the other to minus 3. Since mod of x minus 1 will always be a positive quantity. And what will y max be? Y max will tend to infinity, plus infinity. Because as you keep on increasing mod x minus 1, the value of y will keep on increasing. Right? Then y is equal to x square plus 3. Same story is with x square as well. X square is always greater than or equal to 0, since the square of any real number cannot be negative. So x square is greater than or equal to 0 and you are adding 3 to it. That means again y minimum will be equal to 3. Y maximum will be equal to infinity. It should not be equal to infinity, it should be tending to infinity. Like we cannot determine the maximum value of y, but it will be a very large number. So y belongs to 3 to infinity, 3 close bracket, infinity, open bracket. Then y is equal to x square plus 4x plus 5. Y is equal to x square plus 4x plus 5. We know that the minimum value of y can be found out. We can find out the minimum value of y by minus d upon 4a. Minus d upon 4a. This is the vertex of the parabola. Do you remember? This is the vertex of the parabola minus b by 2a comma minus d upon 4a. So this value of y will give you the minimum value of this expression. How otherwise how can we do this? We can write x square plus 4x plus 5 as x plus 2 whole square plus 1 by completing the square, because see seriously you determined this point by completing the square method. So if you use that method to find out range, there is no problem in that. You x square plus 4x plus 5, you have this expression. You can write this as x plus 2 whole square plus 1. Common sense comes into play where x plus 2 whole square is always greater than or equal to 0. That means 1 is your minimum value and infinity is your maximum value, that is approaching to maximum value. Right? So y will be in between 1 to infinity, 1 closed, infinity open. Y is equal to sin x plus 3. Y is equal to sin x plus 3. Now sin x, you know that it is in between minus 1 and 1. So if you add minus 1 to 3, you will get the minimum value, and if you add 1 to 3, you will get the maximum value. That means y minimum will be equal to 2 and y maximum will be equal to 4. So watching these expressions, you must use common sense and answer. There is no need to do anything else. Right? So this was your first method of finding the range of a function. Second, express x in terms of y. Express x in terms of y. So what happens is you have a function y is equal to fx. You write x is equal to fy, or you can write gy. You write x is equal to gy, and the condition of domain now gives you the range of the function. Right? So what happens is, like if you have y is equal to x minus 3 upon x minus 1, find the value of x from this expression. Find the value of x from this expression. What you will do is you will cross multiply. Xy minus y is equal to x minus 3. You have x is equal to, y minus 3 divided by y minus 1. X is equal to y minus 3 upon y minus 1. If you have this, you know that y cannot be equal to 1 since y is in the denominator, and now this gives you your range. This expression will have y belonging to R except for 1, since y cannot be equal to 1. Right? So you wrote x in terms of y, then you apply the condition of domain, or what possible values y can take, and that gives you the range of the original function. Right? Next, y is equal to x plus 1 divided by x square plus 2x plus 3. If you have a function like this, where you have a linear function above and a quadratic expression in the denominator, what you can do is, again cross multiply, this becomes yx square plus 2xy plus 3y minus x minus 1 is equal to 0, is equal to 0. Now, this becomes yx square plus x into 2y minus 1 plus 3y minus 1 is equal to 0. Now, since x belongs to real numbers, x is real obviously, so we need to get the d. We need to get the d greater than or equal to 0. D must be greater than or equal to 0. This becomes 2y minus 1 whole square minus 4y into 3y minus 1 greater than or equal to 0. Solving this inequality, you will get the range of expression. You will get the values of y, which is in fact the range of this expression. Right? When you write greater than or equal to 0, you need to check the boundary points. You need to check the boundary points. Like, let's suppose if I solve this entirely, what do I get? I get 4y square plus 1 minus 4y. This is minus 12y square plus 4y greater than or equal to 0. So this gets cancelled out. You have 8y square less than or equal to 1, or y belongs to, this will be minus 1 upon 2 root 2 to 1 upon 2 root 2. Minus 1 upon 2 root 2 to plus 1 upon 2 root 2. You need to check these corner values beta. Can y be equal to 1 upon 2 root 2? Just the corner values, nothing else. All the values in between will be satisfied, but only the values on the edge, on the corner. So if you put y is equal to 1 upon 2 root 2 and you get a value of x, your answer is correct. Right? So you will put close bracket minus 1 upon 2 root 2 to plus 1 upon 2 root 2. I hope this is clear. Now in questions like this, you have to be very careful. You have to be very, very careful. I forgot where that is. Yeah. This one is important. And it is not important because it is tough. It is actually very easy, but it can be time taking. And then the students waste time in problem solving, which should have been solved in a very quick time. So y is equal to x square minus 4x plus 3 upon x square minus 5x plus 6. If you go by solving by this method, it will take time. So what you can do is, you can write this expression as, x minus 1 into x minus 3 divided by, this can be written as x minus 2 into x minus 3. Right? You can factorize these two and you can cancel out x equal to x minus 3, but you can do this only if x is not equal to 3. X is not equal to 3. Right? So if you cancel out these two, you get y is equal to x minus 1 upon x minus 2. You get x minus 1 upon x minus 2. So there will be one value of y that is equal to 1, which you will not get. Just similar to this expression. Here you had y is equal to x minus 3 upon x minus 1. Here you have y is equal to x minus 1 upon x minus 2. So y cannot be equal to 1. That is fine. But you have to take care that x cannot be equal to 3. If x cannot be equal to 3 and you put it over here, you will get this as 2 upon 1, that is 2. So if x cannot be equal to 3, y cannot be equal to 2. Y cannot be equal to 2, which implies y belongs to R except for 1 and 2. 1, because when you will cross multiply, you will get x as an expression in which y minus 1 will be in the denominator. So y cannot be equal to 1. And since x cannot be equal to 3, y cannot be equal to 2. I hope this is clear, beta. Right? Now, let's move on to the next. AM greater than equal to GM greater than equal to HM. So for this is another way of finding out the range, right? So for A, B, C greater than 0, you can also write equal to 0. For A, B, C greater than or equal to 0, A plus B plus C divided by 3 is greater than equal to A, B, C raised to the power 1 upon 3 is greater than equal to 3 upon 1 upon A plus 1 upon B plus 1 upon C. Also, in general, it can be written as, x1, x2, x3 till xn, all greater than or equal to 0. This can be written as, or you must not write them to be equal to 0. Please remove the equality sign, since we are dealing with numbers that are in the denominator as well, right? So it is greater than 0, all these numbers. So AM will be x1 plus x2 plus x3 and so on till xn divided by n. This is greater than or equal to x1, x2, x3 and so on till xn raised to the power 1 upon n, and this is greater than equal to n upon 1 upon x1 plus 1 upon x2 and so on till 1 upon xn. So now, since this again involves inequality, it can be useful to give us the range of f. Okay? It can help us to give the range of f. AM is greater than equal to GM is greater than equal to HM. I hope you are aware of what these terms are. I just wrote these short forms. This is the arithmetic mean, this is the geometric mean, and this is the harmonic mean. Right? So I'll take a 1 minute break. You try this question. If 3a plus 2b plus 5c is equal to 20, ABC is greater than 0, then find the minimum value of this expression, a cube b square c to the power 5. Try this question on your own once. If 3a plus 2b plus 5c is equal to 20, and here you needed a cube b square and c to the power 5. So this gives us a hint of breaking 3a into 3 parts. You can do that as a plus a plus b plus b plus c to the power 5 you need. That means c plus c plus c plus c divided by, how many terms are there? There are 10 terms. 3 plus 2 plus 5. This is 10. This is the arithmetic mean of these 10 terms. 3 A's, 2 B's and 5 C's. And this will be greater than or equal to, a cube, since you are multiplying a 3 times, b square and c to the power 5 raised to the power 1 upon 10. This is the geometric mean of these 10 terms. Right? So now 3a plus 2b plus 5c is equal to 20. That means this expression is written as 2. 2 is greater than equal to a cube b square c to the power 5, and this will be written as 10. So a cube b square c5 is less than or equal to 2 to the power 10. That means we had to find out the maximum, in fact. I'm so sorry. You have to find out the maximum value of a cube b square c to the power 5. Maximum value will be 2 to the power 10. 2 to the power 10. I hope I am clear, and sorry for this mistake. Okay, let's move ahead. This was the third method that we did. First method was common sense. second method was express x in terms of y, and third method was am greater than equal to gm greater than equal to hm. Now differentiation. How can we use differentiation to find out range? Look, y is equal to fx. You find out dy by dx, that comes out to be equal to f dash x. That comes out to be equal to f dash x. Now, if f dash x is greater than 0, if f dash x is greater than 0, fx is increasing. Fx is increasing. And if f dash x is less than 0, then fx is decreasing. Then fx is decreasing. If f dash x comes out to be greater than 0, fx increasing. Fx will be an increasing function. And if f dash x is less than 0, fx is a decreasing function. How do we get this? How can we say this? See, if f dash x is greater than 0, that means the slope of the tangent at any point should be positive. Please listen carefully. If I say f dash x is greater than 0, that means slope of the tangent, that is dy by dx, is greater than 0 at any point on the curve. That means the angle which the tangent makes with the x-axis must be acute. And in all these cases, you will see that the angle is always an acute angle. That means dy by dx will be always greater than 0 for an increasing function. Right? Fx is decreasing when we have curves like this. So in these cases, if you draw any tangent, it will always form an acute angle. It will always form an acute, in fact, an obtuse angle. That means tan theta will be negative. Here, tan theta will be negative as theta is obtuse. Here, tan theta will be greater than 0 since theta is acute. Right? So how can you use these in questions? Let us see. Find minimum and maximum value of, that means you have to find the range of this expression when x belongs to 0 to 2. When x belongs to 0 to 2. So if you differentiate this expression, dy by dx is equal to 3x square plus 6x plus 15. Or you can also write it as 3 times x square plus 2x plus 5. This can be written as 3 times x plus 1 whole square plus 4. Now, 4 plus x plus 1 whole square. That means this is always greater than 0. This means that y is an increasing function. Now, if y is an increasing function, so y minimum value will be when x is equal to 0. And y maximum will be when x is equal to 2. Obviously, if you say that the function is increasing in a to b, right? So minimum value will be fa, maximum value will be fb. Here, when you say that the function is decreasing in a to b, minimum value will be fb and maximum value will be fa. Right? You can write over here, fx is decreasing in A to B implies fx minimum will be equal to fb and fx maximum will be equal to fa, and fx maximum will be equal to fa. Over here, fx is increasing in A to B implies fx max will be equal to fb and fx min will be equal to fa. Will be equal to fa. Right? Please note it down. Please note it down. And then you can find out the answer over here. When x is equal to 0, y minimum will be equal to 18. Y minimum will be equal to 18. And y max when x is equal to 2, this will be 8 plus 12, 20, 20 plus 30 will be 50, and 50 plus 18 will be 68. Y max will be equal to 68. I hope this is clear to all of you. Next, trigonometric range. Trigonometric range. And again, you study this in your trigonometry. I'll brief you over here. Like if y is equal to a sin x plus b cos x. If you have y is equal to a sin x plus b cos x, y maximum is root of a square plus b square, and y minimum is minus root of a square plus b square. This is y max, this is y min. Right? This is your trigonometric range. This is how you can find trigonometric range, but please understand that these two angles have to be the same. These two angles have to be the same. You cannot just write trigonometric range with your eyes closed. Because a lot of times you will have expressions like this. You will have 2 sin x1 plus 3 sin x2, or in fact you will be given 3 cos x2, and you are asked the maximum value of y. I know a lot of you students, if I had not mentioned it, you would have answered it to be root 13. Maximum value, you would have answered it as root 13, but that is not the case. Here the maximum value will be, y max will be 5, because individually sin x1 and cos x2 can be equal to 1. Cos x2 has maximum value 1 and sin x1 has maximum value 1. Here it is not possible for both of them to take value 1. Right? Because if sin x is 1, cos x has to be 0, and if cos x has to be 1, sin x has to be 0. So there is a value in between 0 and 1 which we have to keep for sin x and cos x. You get the maximum and minimum value as minus root a square plus b square and root a square plus b square. I hope this is clear. You can apply it in this question. The minimum and maximum value of y is equal to 5 sin x plus 12 cos x minus 4 is equal to. So the thing that concerns you is this expression. Minus 4 will always remain there, right? So 5 sin x plus 12 cos x. If this expression is y1, this is y is equal to y1 minus 4. Y is equal to y1 minus 4. Now y1 max will be equal to 13. This will be root of 5 square plus 12 square. That will be equal to 13. And y1 minimum, this will be equal to minus 13. So the maximum value of y will be 9 and minimum value of y will be minus 17. Will be minus 17. y minimum will be minus 17, y maximum will be equal to 9. Right? Sure. Next question. The minimum and maximum value of y is equal to 4 sine square x plus 2 cos square x plus 10 sine x cos x minus 1. So here you have different expressions of sine and cos, and you also have an expression of sine x cos x. What do? Your brain should go to this expression can be written as, you know that cos 2x is equal to 1 minus 2 sine square x. So 2 sine square x is 1 minus cos 2x. That means 4 sine square x is 2 minus 2 cos 2x. 2 minus 2 cos 2x. Okay. Then this expression 2 cos square x. Now cos 2x can also be written as 2 cos square x minus 1. That means 2 cos square x can be written as cos 2x plus 1. Cos 2x plus 1. This expression can be written as 5 sine 2x. 5 sine 2x. Yes. So y becomes 2 minus 2 cos 2x plus cos 2x plus 1 plus 5 sine 2x minus 1. 5 sine 2x minus 1. So this becomes 3 minus 1 is 2 plus 5 sine 2x minus cos 2x. Now the expression over here 2x and 2x are same. Now you can apply that maximum and minimum value. The maximum value for this expression will be root 26 and minimum value will be minus root 26. So y max will be 2 plus root 26 and y minimum will be 2 minus root 26. Right? Chalo. Let's see the next one. Vectors. How do we find out the range using vectors? There is only one relation that you might have studied in physics. This is A dot B. A dot B. This is equal to magnitude of A, magnitude of B, cos theta. So Cauchy-Schwarz inequality. Cauchy-Schwarz. It states that A dot B divided by magnitude of A, magnitude of B will be less than or equal to 1, and this is so obvious. Cos theta is always less than or equal to 1, right? So A dot B divided by magnitude of A, magnitude of B will always be less than or equal to 1. You can use this to find out the range. Like for example, if in this expression you need to find out if 3x plus 4y is equal to 5 is given, then find the minimum value of x square plus y square. Now thinking in this direction will only come if you know about this law, right? I would never think of this like I have to find out using vectors, but if you are aware of vectors, then you might think of this question in that direction, right? So 3x plus 4y is equal to 5. You have to find the minimum value of x square plus y square. If you let a vector A as 3i cap plus 4j cap, and you let a vector B as xi cap plus yj cap. So what is 3x plus 4y? It is A dot B, right? A dot B will be less than or equal to magnitude of A. Magnitude of A is 5 into magnitude of B is x square plus y square root. That means root of x square plus y square will be greater than or equal to 3x plus 4y is equal to 5. 5 divided by 5 will be 1. Root of x square plus y square is always greater than or equal to 1. So यहाँ से from here you can find out the minimum value of x square plus y square, that will be equal to 1. Right? I hope this is clear. So these were the 5 or 6 methods that we discussed for range. Common sense, express x in terms of y, am greater than equal to gm greater than equal to hm, differentiation, vectors, and trigonometric range. So any other question if there arises, you can use any of these 6 results, or that will probably go in the common sense domain. Okay? All right. So all these 6 methods have to be very well understood. Questions can be seen from any of these point of views. Any of these 6 methods you can solve any of the problems of range, and it is very important. A lot of questions in JEE mains come directly from domain or range. Right? We'll see when we solve the questions how much these are useful. Let's move on to the next. Types of functions. Types of functions. Give me a minute. I'll just okay. So 1-1 and many-one function. When we talk about 1-1 function, here it contains m elements, here it contains n elements. So if you go by that concept of boys and girls, 1-1 function means that there is no competition among the boys. No two boys can have the same crush. No two boys can have the same crush. So one element of the domain will be linked to one element of the codomain. No element of the codomain will have more than one preimage. No element या no two elements of the domain have the same image. No two elements of the domain have the same image. There is no competition among the boys. There is no girl which has two preimages. Okay? There is no element in set B. There is no element in set in the codomain that has more than one preimage. Right? So if m is greater than n, if m is equal to n, if m is less than n. These are the 3 possibilities. We have to find out the number of 1-1 functions, number of many-one functions. So you have to first remember that total number of functions, will be total number of functions. First element of A has how many options to map? N options. Second element has n options. Third element has n options. Remember, 3-4 elements of the domain can go to the same codomain, same element of the codomain. So there is no such restriction. Every element of A will have n options to map. That means n into n into n, m times. This is n to the power m. This is n to the power n. So this is n basically. This is n to the power m. Right? When we talk about 1-1 functions, Please take a look at this. If m is less than n, what will happen is A1 will get mapped to B1, A2 will get mapped to B2, A3 will get mapped to B3, A4 will get mapped to B4, AM will somewhere be mapped to, let's suppose, BM, and there will be elements left over here. Yes? So when m is less than n, 1-1 functions are possible. 1-1 functions are possible because these elements can remain empty. There is no such problem with that. Right? Okay. So if m is less than n, what you do is you select m elements out of n, NCM. You select any m elements out of these n elements, and then you can permute them in m factorial ways. First will have m options, second will have m minus 1 options, third will have m minus 2 options, and so on. So this is NCM into m factorial, which can also be written as NPM. NPM. This is the same when you get m equal to n. When you get m equal to n, this is NPN, which is n factorial. In this case, it will be n factorial. If the number of elements in A and B are the same, first element will have m options, second element will have m minus 1 options, third element will have m minus 2 options, last element will only have 1 option. In this way, you get the number of 1-1 functions. Now, if m is greater than n, in this mapping, in that case, you will get what? A4 gets linked to B4. Now, AN, or I should draw another figure. I should draw a separate one like this. A1, A2, A3, A4, A5, B1, B2, B3. This is A, this is B. If m is greater than n, here there are 5 elements, there are 3 elements. What will happen is A1 gets linked to B1, A2 gets linked to B2, A3 will get linked to B3. Still A4 and A5 are left, and according to our association, every boy must have one crush. That means A4 and A5 cannot be left empty. They will have to go to one or the other element in the codomain. That means in this case, 1-1 functions are not possible. 1-1 functions are not possible. So number of 1-1 functions here will be 0. Number of 1-1 functions will be 0. And how do you get many one function? Subtract these two. In the first case, many one function will be n to the power m. Second case, if m equal to n, so n to the power n minus n factorial, number of many one functions. And if m is less than n, then n to the power m minus npm. Number of many one functions can be found out by subtracting the number of 1-1 functions from the total number of functions. Right? Many one functions, how will we define them? We will define that at least one element of the codomain, has more than one pre-image in the domain, or at least 2 elements of the domain have the same image in the codomain. I hope the name gives you a good idea of what these functions are. 1-1 function and many one function. 1-to-1, that means no element of the codomain has 2 pre-images, and many one function, at least one element of the codomain must have 2 pre-images. Yes? Let's move on to into and onto functions. Okay, so one thing more, remember that 1-1 functions are also known as injective functions. Injective functions. These are 1-1 functions are also known as injective functions. Now we are going to study about into and onto function. Onto functions are also known as surjective functions. Surjective functions. Right? So into and onto functions you have to study. What are into and onto function? Listen, we studied about a function. Now, when we map under the condition f from A to B, and we say that A1 is mapped to B1, A2 is mapped to B2, A3 is mapped to B2, something like this, and every element, or we can write it in simpler terms, that into function is when range is not equal to the codomain. Range is not equal to codomain. That means you can also write this as at least one element of codomain does not have a pre-image. At least one element of codomain does not have a pre-image. Right? There is at least one element empty in the codomain. It is possible, right? We cannot have an empty element in the domain, but we can surely have an empty element in the codomain. There can be a girl without having a crush. Right? So this is range not equal to the codomain, and this is onto function is range equal to the codomain. Every element of the codomain has a pre-image. Every element of codomain has a pre-image. Every element of the codomain has a pre-image. This is how you define onto and into functions. Right? We can find out the range of the function. The codomain is always given in the function. Whenever we write a function, we write it as f from A to B. So this A is your domain, B is your codomain, and fx is given to be something. When we find out the range of fx and it comes out to be equal to b, then we say that it is onto. If it comes out to be a subset of b, then we say that it is an into function. Right? So again, there arise three cases. Three cases will be m greater than n, m equal to n, and m less than n. Right? M greater than n, m equal to n, and m less than n. Total number of functions will still remain n to the power m. Total functions will be n to the power m. Now we have to find out the number of onto functions. I'll tell you the formula because this is derived using inclusion-exclusion principle in permutation and combination. If you don't know it yet, you won't know it again. I cannot explain it in functions, how to find out the number of onto functions. We'll write the formula. We'll probably learn it now. Okay? You don't have the enough time to understand this concept of PNC if you don't know it yet. You memorize this formula. So first consider the three cases. You have A1, A2, A3, A4, A5. You have B1, B2, B3. This is set A, this is set B. You can get an onto function like this. You can get an onto function like this. So A2, B2, A2, this can go to B2, this can go to B3. No problem. This is absolutely fine. But what happens if A has less elements than B? A1, A2, A3, and this is B1, B2, B3, B4. Now A1 will go to B1, A2 will go to B2, A3 will go through B3. Now B4 cannot have a pre-image. B4 cannot have a pre-image. That means you will always get into functions when m is less than n. Onto functions will be 0. Onto functions will be equal to 0 in this case if m is less than n. Right? So m equal to n and m greater than n. In this case, the formula becomes of onto functions n to the power m minus nc1 n minus 1 to the power m plus nc2 n minus 2 raised to the power m minus nc3 n minus 3 raised to the power m, and so on till the time it goes to 0. It will continue. So this is total minus exclusion, then inclusion, then exclusion, and so on. This is the number of onto functions that you have to remember. N to the power m minus nc1 n minus 1 to the power m plus nc2 n minus 2 to the power m, and so on till you get a value 0 in the end. Got it? I hope this is clear, beta. This is the total number of functions n to the power m. This is the number of onto functions. You can get the number of into functions as well. ये दोनों, this is valid for both of these cases. Right? Now, before going to even and odd functions, we have to consider the combination of these functions as well. Like the first will be 1 1 on 2. The second one will be many 1 on 2. Third one will be 1 1 in 2, and fourth will be many 1 in 2. Right? 1 1 on 2. It is necessary in this case 1 1 on 2, in case of 1 1 and on 2, it is necessary that m has to be equal to n. M has to be equal to n. So if in case you define a function f from a to b, you get a 1 1 on 2 function. And 1 1 on 2 function combined, like see, this is injective, this is surjective. Combined, these two are known as bijective functions. Bijective functions. Why are they significant? Why are only these having a name 1 1 on 2 and 1 1 on 2? I'll tell you in a while. But just remember, 1 1 on 2 functions are also known as bijective functions, and 1 1 on 2 function will only be possible when m is equal to n. Next, many 1 on 2. Many 1 on 2. This is many 1 on 2. So A1, A2 have the same image, that means it is many 1, and all the elements of the codomain are having a pre-image, that means it is on 2. So many 1 on 2 can be written in this way. Then 1 1 in 2. This is 1 1 function, and since B4 does not have a pre-image, it is an into function as well. So this is a 1 1 into function. Many 1 into. This is a many one function since A1, A2 and A3 have the same image, and since B2 does not have an image, does not have a pre-image, it is an into function. So B2, so this function f is a many one into function, right? Now, why is this special privilege for this only? What special privilege? Written in pink. Why is it written in pink? Why is it significant? It is significant because for only bijective functions, inverse exists. Inverse exists only for bijective functions. That means if you want to write a function from B to A for this mapping, you can write. What are inverse functions? The domain becomes the codomain and codomain becomes the domain. This is how you define a bijective, an inverse function. It is the replica of the graph about the line y is equal to x. We'll study inverse in a while, but you understand that if you want to define a function from B to A on this mapping, you can define. If in case I want to define function from B to A, you cannot, because one element will have two images, hence it is not a function. Then when you come to this, if you want to define inverse, B4 does not have an image in A. Like if you find out the inverse, if you swap sets A and B, it will not be a function anymore. Similarly, in this case, B1 has three images and B2 does not have an image. That means again it will not be a function. So only for bijective functions, inverse exists. Inverse exists. Right? That is why this important important topic is given in as inverse of a function, and it is valid only for bijective functions. That means 1, 1 on 2 functions. I hope this is clear, beta. So moving on to the next thing that we have to study in many one, 1, 1 on 2 and into function is how to determine these functions, whether they are 1, 1, whether they are many one, and so on. So for 1, 1 and many one, we have two ways. One is by contradiction, and second is by a graphical method, that is horizontal line test. Horizontal line test, right? So by contradiction, what do we do? As you would have done in your school exams, let fx1 is equal to fx2. You have to check the one-oneness of a function fx, right? So what you do is you let that function to be a many one function. You say that corresponding to two values x1 and x2, you are getting the same value of fx, right? Now from here, if x1 is equal to x2 is the only solution, if x1 is equal to x2 is the only solution, we say that fx is 1, 1. We say that fx is 1, 1. Otherwise, it is a many one function. If there is a solution different from x1 equal to x2 as well, then we say that the function fx is many one, right? So this is by the method of contradiction. Now the horizontal line test. If you have a graph, you draw infinite horizontal lines. You draw infinite horizontal lines. If any one of the line cuts the graph at more than one point, we say that it is a many one function. We say that it is a many one function. Why is it so? Because for three values of x, for three different values of x, this is x1, this is x2, and this is x3. For three different values of x, that means three values in the domain, you have the same image in the codomain. you have the same image in the codomain. That means it is a many one function. If you want a one function, every horizontal line should cut the graph at only a single point. In this case, it will be a one function. For into and onto function, I have already told you, you are given a function, you are given the codomain of the function. You find out the range. If range is equal to the codomain, it is an onto function. If range is a subset of the codomain, it is an into function. Right? So this is how you judge one and onto functions. In fact, one, many one, and onto, into I have already told you. Next, we move on to even and odd functions. Even and odd functions. A function fx defined on the symmetric interval minus a to a. If f of minus x is equal to fx, if f of minus x is equal to fx for all x in the domain of f, then f is said to be an even function. Even function, when do we get it? When f of minus x comes out to be equal to fx. Like for example, in case of fx is equal to x square, fx is equal to cos x, and so on. In fact, fx is equal to mod x as well. So in this case, it is an even function. If f of minus x is equal to minus fx for all values of x in the domain of f, then f is known as an odd function, as in the case of x cube, sin x, and so on. Right? So for an even function, you have f of minus x is equal to fx, and odd function you have f of minus x is equal to minus of fx. Right? The even functions that you have, these are symmetrical. These are symmetrical about y-axis. These graphs are symmetrical about the y-axis. You would have seen y is equal to x square, y is equal to mod x, and y is equal to cos x. They all are symmetrical about the y-axis. Similarly, if you talk about odd functions, these are symmetrical. These are symmetrical about the origin. These are symmetrical about the origin. Right? So you have fx is equal to, ln of x plus root of 1 plus x square. And on seeing this expression, you feel that if I replace x by minus x, you have three options. You can tell this to be odd, you can tell this to be even, or you can tell this to be nano. Nano is neither even nor odd. Right? So on looking at this question from the outside, it feels that if I find out f of minus x, I will get ln of minus x plus root of 1 plus x square. Because if you replace x with minus x in x square, it will still remain the same. Now, these two don't look identical, right? And neither does it look it to be minus of f of minus x. But don't decide by just looking at it. Solve it a bit more. What do you get? You get fx plus f of minus x. Solve this. Fx plus f of minus x. This will be ln a plus ln b. So that means this is what? Ln of a into b. So this becomes ln of x plus root 1 plus x square into minus x plus root of 1 plus x square. What is this? This is a plus b into a minus b. What is it? A square minus b square. This is ln of a square minus b square, which is equal to ln 1, which is equal to 0. Now, since fx plus f of minus x is equal to 0, you get fx or f of minus x is equal to minus of fx. F of minus x comes out to be equal to minus of fx, and hence it is an odd function. Hence, it is an odd function. This is how you decide whether a given function is even or odd. You replace x with minus x. If you get fx is equal to, in fact, f of minus x equal to fx, it is an even function. If you get f of minus x equal to minus fx, it is an odd function. If it satisfies none of these two conditions, it is neither even nor odd. I hope this is clear. Coming on to the next question. Fx is equal to 1 upon root 1 minus x square minus x into x into GIF of x square. Again, on seeing this question from the outside, it feels as if x square will remain x square. This x square will remain x square. This will become plus. That means it feels as if no, it is neither even nor odd. But again, think about it. Look at the question from different perspectives. You will arrive at a result. See, 1 minus x square is written under the root and it is written in the denominator. That means 1 minus x square is greater than 0. If 1 minus x square is greater than 0, then x square is less than 1 and obviously it is greater than equal to 0. X square is always greater than equal to 0 and it is less than 1. In that case, greatest integer of x square, this will be equal to 0. That means this quantity is 0. Fx is only 1 upon root of 1 minus x square. And in that case, this function is an even function. This function is an even function. Right? So always odd and even functions will not be visible from the outset. You have to solve it a bit and then you can arrive at the result. I hope I am clear with both these examples. This is an odd function, that is an even function. Both the questions were not looking like odd and even from the outset, but upon solving you get these results. Let's move on to the next question, or in fact next concept of periodic function. Next concept of periodic function. A function fx is called a periodic function if there exists a positive number t called the period of the function such that f of x plus t is equal to fx. The graphs or the functions which repeat itself after a certain interval, you get the same values after t interval. F of x plus t equal to fx. In that case, these are known to be the periodic functions. And t is known as the fundamental period of fx. Right? So constant function, since it repeats itself again and again, there is no fundamental period. There is no fundamental period, but it is periodic. A constant function is periodic with no fundamental period, right? Then if fx has period t, root fx 1 upon fx also has period t. Till the time you don't touch this x, I'll tell you in the next slide, when does the period of a function change. Till it is root fx or 1 upon fx, it doesn't matter. The period of the function will still remain the same. If fx has period t, root fx 1 upon fx also has period t. Right? I hope first and second points are clear. Then the third point. If fx is periodic with period t and gx is also periodic with period t, fx is also periodic with t, gx is also periodic with t, then fx plus gx has period t. Is this so? Is it always true? Is it necessary? No, it is not necessary. Why? Because fx plus gx can have a period less than t as well. Like for example, fx is equal to sin x mod. It has a period of pi. gx is equal to mod cos x. This also has a period of pi. Mod sin x period pi, mod cos x period pi. If you write fx plus gx, this will be periodic with period pi by 2. This will be periodic with period pi by 2. So in that case, the period does not remain t, it becomes t by 2. When I talk about the period of this function, I am sure you must have heard that sin x cos x is periodic with period 2 pi, tan x is periodic with period pi, fractional part of x is periodic with period 1. These are the functions that we commonly use in periodic functions, right? Trigonometric functions are periodic, fractional part is periodic. Also, see, I hope this is clear that if two functions have the same period t, it is not necessarily that their sum will also be periodic with period t. How do we find the period of a function? If we add two functions, then fx and gx LCM of the period gives the LCM gives the period of fx plus gx. So if I say fx is periodic, gx is periodic, fx plus gx has to be periodic, that will be wrong. Fx plus gx will be periodic, that will be wrong. Like, let's suppose you are listening to this and you are saying, Aisa, how is it possible? Fx is also repeating itself, gx is also repeating itself. If we add these two, the LCM of the two periods will give me the period of the fx plus gx. Why is it not repeating? It is because, see, if fx is periodic with period t1 and gx is periodic with period t2, fx plus gx is periodic with period LCM of t1 and t2. But what if LCM is not possible of t1 and t2? You have to remember that LCM of rational and irrational does not exist. Rational and irrational's LCM does not exist. So if I write fx is equal to fractional part of x and gx I write it as sin x, the period of fx is 1 and period of gx is 2 pi. So LCM of 1 and 2 pi does not exist. Yes, 1 and 2 pi ka LCM, the LCM of 1 and 2 pi is not 2 pi. It does not exist, right? So fx plus gx may or may not be periodic. Remember this. Okay. Then if fx has period t, then f of ax plus b has period t upon mod a. This is what, when I was saying, I'll tell you when does the period of a function change. Root fx period does not change, 1 upon fx period does not change, but f of ax plus b, now the period changes to t upon mod a. That means you can see that if I had put a as 1, f of x plus b, still the period will be t. Still period will be t. But since I put a is equal to not a number equal to 1, the period becomes t upon magnitude of a. Right? So in fact, this tells us that period of sine 2x will be 2 pi divided by 2, that is equal to pi. Sine 3x will be periodic with period 2 pi by 3 and so on. Right? But if I ask you sine x plus pi by 4, sine x plus pi by 4, this will be periodic with period 2 pi. Since x has been written with 1, the period will remain 2 pi. Right? I hope this is clear. Next, discontinuous functions. When we have discontinuous functions, like let's suppose tan x is a discontinuous function in R. Tan x is a discontinuous function in R. It has breaks, but still the break is also periodic. After an interval of pi, the break repeats itself. That means tan x is periodic with period pi. Similarly, if you talk about fractional part of x is again a discontinuous function. It again repeats its discontinuity after a interval of 1. This is the graph of fractional part of x. So this is repeating itself after an interval of 1. That is why the period of fractional part of x is 1. right? Let's move on to the questions for this. Find period of fx is equal to sin x plus cos x. Sin x plus cos x. This is periodic with period 2 pi. This is periodic with period 2 pi. LCM of 2 pi and 2 pi will be 2 pi. But do check it at their half as well. Whenever you get a period, just check it at its half value. If it is not coming out periodic, move ahead. So the period of fx is equal to sin x plus cos x will be 2 pi, but we have to check it at pi as well. So f of x plus pi, this is equal to sin of x plus pi plus cos of x plus pi. So this gives me minus sin x and this gives me minus cos x. Since f of x plus pi is not equal to fx, we can say that 2 pi is the fundamental period of fx. Right? I have already told you this answer. Fx is equal to mod sin x plus mod cos x. This is periodic with period pi. This is periodic with period pi. You'll take the LCM, you'll get pi, but do check it at half. That is pi by 2. This gets converted to this and this gets converted to this. So the sum remains the same. That is, the period will become pi by 2. Right? Now fx is equal to sin cos x. I know cos x is periodic with period 2 pi. I'll keep it like that, 2 pi. But check it at pi as well. Check it at pi as well. F of x plus pi will be equal to sine of cos of x plus pi. This is sine of minus cos x, which is equal to minus of sine cos x. Since this is not equal to fx, it will be periodic with period 2 pi. It will be periodic with period 2 pi. But in this case, fx is equal to cos of sin x. I know again 2 pi ke baad, I know that after 2 pi it will definitely repeat, but we have to check it at pi as well. In this case, f of x plus pi will be equal to cos of sin pi plus x. This is cos of minus sin x, which is also equal to cos of sin x, since cos of minus x is equal to cos x. Now since f of x plus pi is coming out to be fx, this is periodic with period pi. You have to be careful in this beta. Right? I hope this is clear. I hope this is clear. Let's move on to the next. Fx is equal to sine pi by 2, greatest integer of x. This is GIF function. This is also GIF function. I'll tell you this, you have to do this yourself. This one is do it yourself. I'll tell you the method. It's very, very simple. But you have to try this question once because you might not see these questions everywhere. They are available, but it might be that this concept skips out of your practice. So you practice this question right here. Fx is equal to sine pi by 2, greatest integer of x. You start from, like when we have greatest integer, we generally plot the intervals like 0, 1, 2, 3, 4 and so on. Right? In between 0 and 1, greatest integer of x will be 0. That means sine pi by 2 into 0 will be sine 0, and that is equal to 0. From 0 to 1, fx will be equal to 0. Now, when x is in between 1 and 2, this is sine pi by 2 into 1, that is sine pi by 2. That means you are standing at 1 till the point x equal to 2. When you put x equal to 2, you get this as sine pi, that is equal to again 0. So this is from 2 to 3, this is sine pi, that is equal to 0. That is equal to 0. Then from 3 to 4, this is 3. That means sine 3 pi by 2, that is equal to minus 1. That is equal to minus 1. Upon reaching 4, again you reach the value 0, and this graph repeats itself. This graph repeats itself. After this, again you will get the same graph. That means period of the function will be 4. Period of the function will be 4. Fx is equal to sine pi by 2 greatest integer of x is periodic with period 4, since this entire same graph will be repeated from 4 to 8, 8 to 12 and so on. Right? So practice this question on your own. Look at this solution, understand it and then try. Okay, let's move on to the next. A function f which satisfies f of x plus 4 plus f of x minus 4 equal to fx for x belonging to R is periodic with period. So every equation of this form is periodic. We need to find a t such that f of x plus t comes out to be equal to fx. We have to find such a condition for this given equation, right? So what you do is looking at this x plus 4, x minus 4 and x. If you replace x by x plus 4, you get f of x plus 8. This will become fx and this will become x plus 4. If you add these two equations, you see this will get cancelled out with this and this will get cancelled out with this. What do you get? You get f of x plus 8 plus f of x minus 4 is equal to 0. Right? Now, convert this into this or this into this. So what you have to do is, you have to replace x by x plus 12. If you replace x by x plus 12, you get f of x plus 20 plus f of x plus 8 is equal to 0. Right? Convert this into this or this into this. I converted f of x minus 4 into f of x plus 8. Now if you subtract, you cancel out this and what do you get? You get f of x plus 20 is equal to f of x minus 4, since it will be with a minus sign. Yes, so f of x plus 20 will be equal to f of x minus 4. Now replace x by x plus 4. You get f of x plus 24. This is equal to fx. You see, this is the same form like this and the value of t becomes 24. The value of t becomes 24. I hope this thing is clear, beta. Look at this solution once, understand it. You get a lot of questions like this. I hope this is clear. Okay, so moving on to the next concept, that is for composite functions. And again, see, understanding the theory between this composite functions, drawing its graph, they are all good from learning point of view, from understanding the concepts point of view. But now you have to be result oriented. You have to be questions oriented. So what happens is, like if you have a function from a to b, this is f, and you have a function g from b to c, then the function from a to c will give you g of fx. Okay? This is one thing that we all know. The thing that matters to us, the thing which is important for us is this, that range of f, when we write g of fx, range of f must be a subset of domain of G. This, if you understand, there is no problem with composite functions, right? So domain of, in fact, range of f, when you write G of fx instead of G of x, so you are putting fx in place of x. So that means fx range must be the same as or a subset of the domain of G. g. Right? So you'll get questions, you will understand through those questions. If fx is equal to root x and gx is equal to root of 2 minus x, then find the domain of f of gx. How do we write f of gx? F of gx will be equal to root of gx, which is root of 2 minus x. Root of 2 minus x. We have to find the domain of this. So when we write f of gx, the range of gx, that is, what is the range of gx? It is 0 to infinity. It is 0 to infinity. This must be a subset of the domain of f. And domain of f is again 0 to infinity. Right? So it is quite possible. This thing we can write. Right? So 2 minus x root of 2 minus x must be greater than equal to 0, or you can write 2 minus x must be greater than equal to 0. You write x less than equal to 2. X should be less than equal to 2, and since we are talking about root x as well, since fx is also defined, right? F of gx, if it is defined, it has to be greater than equal to 0. Right? So x must be greater than equal to 0 and less than equal to 2. Less than equal to 2. For f of gx to be defined, x has to lie in between 0 to 2. Or can it be minus infinity to 2? Wait. F of gx. So gx range must be a subset of the domain of f, and gx must be defined. Yes, f of gx will be defined. You don't need to put 0 less than equal to. X must be less than equal to 2 is sufficient. Because see, for x less than equal to 2, gx will always give me a value which will be greater than equal to 0. Yes? So if it is giving me greater than equal to 0, my domain of f is already satisfied. That is the thing. So x will be less than equal to 2 in the first case. Then in the second, g of fx. This is equal to, g of fx will be equal to root of 2 minus fx, which is root of 2 minus root x. 2 minus root x. Right? So first thing first, fx must be defined. That means x must be greater than equal to 0. X must be greater than equal to 0. Then fx range will be 0 to infinity. Fx range will be 0 to infinity, but it must lie in the domain of gx. Domain of gx is minus infinity to 2. So you can write domain of g is minus infinity to 2 and range of f is 0 to infinity. So if you get an intersection of these two, so the range of f must belong to 0 to 2 only. Range of f must belong to 0 to 2 only. That means root x is less than equal to 2 and greater than equal to 0. Root x must be greater than equal to 0, less than equal to 2. That means x is less than equal to 4 and greater than equal to 0. X is greater than equal to 0 and less than equal to 4. Right? You can also solve it using 2 minus root x must be greater than equal to 0. You will get your answer from there as well. Right? Root x will be in between 0 and 2. I hope this is clear, beta. I hope this is clear. G of g will be what? G of g will be root of 2 minus root of 2 minus x. Root of 2 minus root of 2 minus x. So you know that 2 minus root of 2 minus x must be greater than equal to 0. Root of 2 minus x root of 2 minus x must be less than equal to 2, and it will always be obviously be greater than equal to 0. Right? So 2 minus x will be less than equal to 4, greater than equal to 0. Can I write it here only? 2 minus x will be less than equal to 4 and greater than equal to 0. So it will be minus 2 and that will be 2. Minus x belongs to minus 2 to 2. That means x also belongs to minus 2 to 2. Here x will belong to minus 2 to 2. You'll get this answer by solving this. Try it once. You will be able to get this answer. X belongs to minus 2 to 2. Right? Next, inverse functions. Inverse function, as I told you, exists for bijective functions only. Bijective functions only. This is the first point. Second point is like if f is a to b, f inverse will be b to a. If f is a function from a to b, f inverse will be a function from b to a. That means the range of f becomes the domain of f inverse, and the domain of f becomes the range of f inverse. In this case, I say range or codomain, it is one and the same thing because we are talking about bijective functions. Here, range and codomain are the same. Right? Third thing is graph of fx and f inverse are mirror image about y is equal to x. Graph of fx and f inverse x are mirror image about y is equal to x. Right? Then how do you find the inverse? You find the inverse, finding inverse. You studied one method in range, express x in terms of y. Right? So express x in terms of y, then interchange x and y. You will get the inverse function. So I'll tell you one method via this. I'll find out one inverse via this method, and second method can be like if you are talking about, let's suppose if gx is the inverse of fx, implies f of gx is equal to g of fx is equal to x. F of gx will be equal to g of fx will be equal to x. So these are the two methods. This is method number 1. This is method number 2, with which you can find out the inverse of a function. So I'll use this method over here. R is a function which goes from f is a function which goes from r to 0 to 1. Fx is equal to this. So y is equal to 2 to the power x upon 2 to the power x plus 1. If I cross multiply, this is y into 2 to the power x plus y is equal to 2 to the power x. Right? This implies 2 to the power x is equal to y upon 1 minus y. Y into 2 to the power x, you take it to the right side, 2 to the power x common, 1 minus y, take it in the denominator. Now take log both sides. Take log both sides. This will be x ln 2. This is equal to ln of y upon 1 minus y. You get x is equal to log y upon 1 minus y base 2. Okay, this is a property. ln a upon ln b can be written as log a base b. So you get this x in terms of y. Now replace x and y. Now replace x and y. This becomes y is equal to log x upon 1 minus x base 2. This is the inverse function of this. That is the inverse function of this. What did I do? I find out x in terms of y and then I replace x and y. Right? The second method is also one of the same things only. It is nothing different. It's just different representation. So you will write y is equal to, or this is fx basically. This is fx is equal to 5 to the power ln x. What you do is you put x, you put gx in place of x. You put gx in place of x. This implies 5 to the power ln gx, that will be equal to x. That will be equal to x. So 5 to the power ln gx is equal to x. From here you can find out gx by taking log again. So this will be ln gx into ln 5 is equal to ln x. So ln gx will become ln x base 5, right? And then you can compare. Matlab you will be able to solve this question. You look, 5 to the power ln gx, this is equal to x. Take log both sides. This is ln of gx into ln 5 is equal to ln x. Ln of gx, this is equal to log x base 5, or gx becomes e to the power log x base 5. This is your inverse function of fx. This is your inverse function of fx. Y is equal to 5 to the power ln x will have this inverse. Right? I hope this thing is clear with it. Next, find out the inverse. Let f 2 to 4, x belongs to 2 to 4, to 1 to 3 be a function defined by fx is equal to x minus greatest integer of x minus x upon 2. Then f inverse is equal to. Now listen, don't just get carried away by saying that greatest integer function is a many one function. Its inverse does not exist. Its inverse, yes, in R it does not exist since it is a many one function, but here x is given to be 2 to 4. X belongs to 2 to 4. This implies x by 2 belongs to 1 to 2. X by 2 belongs to 1 to 2, which implies greatest integer of x upon 2 is equal to 1. Greatest integer of x upon 2 will be equal to 1. That means fx becomes equal to x minus 1. Now if fx is equal to x minus 1, you can write this as y is equal to x minus 1. You find out x equal to y plus 1 and replace x and y. That means y is equal to x plus 1 is the inverse of this. F inverse x will be equal to x plus 1. In fact, it can be a more than 1 correct. It can be C option as well. This is also equal to 1 only. So x plus 1 can also be written like this. So F inverse will be equal to x plus 1 or x plus greatest integer of x by 2. Right? I hope this is clear, beta. I hope this is clear. Let's move ahead. Let's move ahead. So I give you a space when I move aside. You can write it down by pausing the video. Maintain these notes. It will be useful when you do your last minute revision as well. So these are the topics and these are the good repetitive questions that you see. Okay. So next, now coming to the questions of previous year questions, JEE mains. I have picked a few because we have done a lot of questions with the topics as well. So you will find how many questions. I won't solve all. Still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 questions are there. 21 questions are there. I'll try to give you the hints of maximum of these, but there is no point of me solving all the questions. You can also practice these, right? So a few questions will be given to solve yourself, which will be on the same ground, same concepts, and rest of the questions you can see how I solve and then you can solve it yourself. Okay. So first question says the domain of the function fx is equal to sin inverse 3x square plus x minus 1 upon x minus 1 square plus cos inverse x minus 1 upon x plus 1. So you have sin inverse as well as cos inverse, right? So both of these values should be in between -1 to 1. That means you have to take intersection. So x minus 1 upon x plus 1, this should be less than equal to 1, greater than equal to -1. Yes. Also 3x square plus x minus 1 divided by x minus 1 square should be less than 1 and greater than equal to -1. Since sin inverse and cos inverse both have domain -1 to 1. Right? Now, if you solve this, if you try to solve this, take 1 to the left hand side, or you can write this as 1 minus 2 divided by x plus 1 less than equal to 1, greater than equal to -1. Subtract 1 from all three. Subtract 1 from all three. This is -2 less than equal to -2 upon x plus 1 less than equal to 0. Less than equal to 0. So if you divide it by 2, both sides, -1 less than equal to -1 upon x plus 1 less than equal to 0. Take negative all three sides. This will be 0 less than equal to 1 upon x plus 1 less than equal to 1. Right? Now 1 upon x plus 1 belongs to 0 to 1. That means x plus 1 belongs to, how can you see it? See, if 1 upon x belongs to 0 to 1, zero cannot have close bracket, 0 to 1, right? This value won't be equal to 0. There will be an open bracket. I'll tell you the reason. 0 will be obtained when x will be infinity. X equal to infinity has an open bracket, so 0 will also have an open bracket. If 1 upon x belongs to 0 to 1, this is the graph like this. 0 to 1, if x belongs to, in fact, this is y is equal to 1 upon x. If y belongs to 0 to 1, x belongs to this point will be 1 and this will be infinity. So if y belongs to 0 to 1, x belongs to 1 to infinity. Here x plus 1 belongs to 1 to infinity. If you subtract 1 from both, you will get x belongs to 0 to infinity. So for this to hold true, x belongs to 0 to infinity. Right? X belongs to 0 to infinity for cos inverse. Now, this option is excluded. B cannot be the answer since x belongs to 0 to infinity. Rest of the three can be your answers. Let us see. Now this expression, this is 3x square plus x minus 1 less than equal to x minus 1 whole square, and this is minus of x minus 1 whole square. How did you cross multiply, sir? Cross multiplication is not allowed. Yes, it is not allowed when we are not sure of the sign of the denominator. Here I know x minus 1 whole square will always be a positive quantity. That's why I can cross multiply. Right? I am not taking x equal to 1. That is fine. I will not take the value x equal to 1. I have to exclude that. Okay. So what does this give me? Solve these two. This will be 3x square plus x minus 1 less than equal to x square plus 1 minus 2x. This becomes 2x square plus 3x plus 2 less than equal to 0. in fact minus 2. Right? So this becomes 2x square plus 4x minus x minus 2 less than equal to 0. This is 2x into x plus 2 minus 1 into x plus 2 less than equal to 0. This is x plus 2 into x minus half less than equal to 0. X belongs to minus 2 to half. X belongs to minus 2 to half. X belongs to minus 2 to half from the right side. Now from the left side, what do you get? I don't like turning pages in the middle of the solution. I'll solve it here only. You write it down neatly, cleanly in your notebook. Right? Because if I switch pages, there is a chance of a silly mistake happening. I don't want that. I want to solve the entire question on this page only. Please bear with me. This is what? This is 3x square plus x minus 1 plus x minus 1 whole square. This is x square plus 1 minus 2x. This is greater than equal to 0. So you get 4x square minus x greater than equal to 0. This implies x into 4x minus 1 greater than equal to 0. This implies x belongs to minus infinity to 0 union 1 by 4 to infinity. Minus infinity to 0 union 1 by 4 to infinity. Now you have to take the intersection of all these three. Intersection of all these three values. It says positive values. That means negative values we will remove. We are talking here about 0 to half, and we are talking here about 1 by 4 to infinity along with 0. 0 is included in all those expressions. All three expressions, there is 0. So that means we are talking about 1 by 4 to 1 by 2 union 0. 1 by 4 to 1 by 2 union 0. See, 1 by 4 to 1 by 2 is in this as well as in this. Here, 0 to infinity. So x belongs to 1 by 4 to 1 by 2 union 0. 0 will be there in the answer. It is present in all the three cases. Right? Okay, I'll just be back in a second. Just a second. Yeah. Let's move on. Let's move on to the next question. Let's move on to the next. If the domain of the function fx is equal to cos inverse root of x square minus x plus 1 divided by root of sin inverse 2x minus 1 upon 2 is the interval alpha to beta, then alpha plus beta is equal to, again this is the question of domain. You have to be careful about, first thing, root of x square minus x plus 1. Root of x square minus x plus 1 should be less than equal to 1 and greater than equal to 0. It cannot be negative. It cannot be in between minus 1 to 1. It has to be in between 0 and 1. Right? Then the second thing is root of sin inverse 2x minus 1 upon 2. That means sin inverse 2x minus 1 upon 2 has to be greater than 0. Has to be greater than 0. And sin inverse is one thing which belongs to the interval minus pi by 2 to pi by 2. Since it is greater than 0, that means sin inverse 2x minus 1 upon 2 is greater than 0 and it is less than or equal to pi by 2. That means 2x minus 1 upon 2 is less than or equal to 1. It is greater than 0. Right? So from here, from this equation, you get x is less than half. You get x is less than half. And from this side, you get 2x minus 1 is less than equal to 2, or x is less than equal to 3 by 2. X is less than equal to 3 by 2. x is greater than, okay, that is x is greater than half. Sorry, this is x is greater than half, and here x is less than equal to 3 by 2. So x belongs to half to 3 by 2, right? X belongs to, for sine inverse expression, x belongs to half to 3 by 2. I don't think so anything will be visible with that color. X belongs to half to 3 by 2. Right? This is for the sine inverse part. Now, x square minus x plus 1 must be less than equal to 0. This gives me x square minus x plus 1 less than equal to 1 greater than equal to 0. If you subtract 1 from all, and see, this quantity is obviously definitely greater than 0. This expression's d is less than 0. Yes, so it will obviously be greater than 0. Let us solve for the right side. This is x square minus x plus 1 is less than equal to 1. X square minus x is less than equal to 0. Or x belongs to 0 to 1. X belongs to 0 to 1. Right? So x belongs to 0 to 1. From here you get half to 3 by 2. That means your final answer is half to 1. Yes, if you have to take the common values, it will be x belonging to half to 1. So half is in the open bracket, alpha is equal to half and beta is equal to 1. You add, you get 3 by 2. You add these and you get the value 3 by 2. Yes, I hope this is clear, beta. I hope this is clear. This is question number 2. Next question. Let greatest integer x denote the greatest integer where x belongs to R. If the domain of the real valued function, it's again up to domain. I'll tell you the rule, you solve it yourself and you get the answer. You write it in the comment section. Right? This is question number 3 that is given as homework. You can write answer of question number 3 is this. So what does the question say? Fx is equal to root of mod greatest integer x minus 2 divided by mod greatest integer x minus 3. You have to tell the domain of this. That means mod of greatest integer x minus 2 divided by mod greatest integer x minus 3 is greater than or equal to 0. Is greater than or equal to 0. Right? So what you can do is, you can write, like if you let greatest integer x equal to t, you can write mod of greatest integer x belongs to, if this is greater than equal to 0, it will be minus infinity to minus 2 union 3, in fact minus infinity to 2, minus infinity to 2 union 3 to infinity. 3 will be in open brackets and 2 will be in closed brackets. Yes, I had to give you a hint. I am telling you the solution. Mod of greatest integer x belongs to this, right? So now you have to understand that since it is mod, it cannot be negative. So you can write greatest integer x belongs to, with a mod, belongs to 0 to 2 union 3 to infinity. Union 3 to infinity. It cannot be equal to 3. Remember. Now, if this is mod, then greatest integer x belongs to, understand, this will be minus 2 to 2 union 3 to infinity will give me minus infinity to minus 3 union 3 to infinity. If mod x belongs to 5 to infinity, x belongs to minus infinity to minus 5 union 5 to infinity. Yes, because we overlap the negative values with the positives one. Now, this is greatest integer x. Now, if greatest integer x belongs to minus 2 to 2, that means x belongs to minus 2, when do you get the greatest integer to be minus 2? As soon as it is less than minus 1, right? So this will be minus 2, and when is the greatest integer equal to 2? Up till point 3. So minus 2 to 3, please understand this. If greatest integer x belongs to minus 2, say 2, you get x belonging to minus 2 to 3. Yes. Now if greatest integer x belongs to minus infinity to minus 3, it cannot be equal to minus 3. It is just a value slightly less than minus 3. That means it belongs to minus infinity to minus 4. Minus infinity to minus 4. It cannot be values even less than minus 3. Right? Because in that case, greatest integer will be minus 4. You can keep it a minus 3. You can keep this minus 3 only. You cannot take equal to minus 3, because as soon as you take less than minus 3, greatest integer will become minus 4, and that is included. But in the right hand side, it is 3 to infinity. This will give you 4 to infinity. You cannot take x in between 3 to 4, because for that, greatest integer will be 3, and that is not allowed. Right? So I have discussed the entire domain. Minus infinity to a, that means a is minus 3. B to C, B will be equal to minus 2. C will be equal to 3. And you have to find the value of A plus B plus C. Minus 5 plus 3 minus 2. C option will be correct. Please understand, you have to learn these transformations. It is not entirely upon big questions, big expressions. These small manipulations can fetch you 4 to 8 marks easily. Right? So you have to be very cautious here. Mod and greatest integer both have a certain domain, both have a certain range. When you take x belonging to a certain interval, you need to see where that greatest integer x or mod x lies. Right? You have to be very careful about that. I hope this is clear, beta. Question number 4. If the functions are defined as fx equal to root x and gx equal to root of 1 minus x. Now this is your homework question. This is your homework question. Solve it simultaneously. You have to tell me the domain of f plus g, f minus g, g upon f and g minus f, where you are given the definitions of the functions. You can easily do these questions. Right? Write down question number 4 and write down the answer. All these expressions will have the same domain. You have to pick out of these 4, or in fact the intersections, right? You have to find the intersection of these functions, domains of these functions, and you have to tell the options. Now next, a function fx is given by fx is equal to 5 to the power x divided by 5 to the power x plus 5. Then the sum of the series f of 1 upon 20 plus f of 2 upon 20 plus f of 3 upon 20 and so on till f of 39 upon 20. Now, when these expressions arrive in front of your eyes, what you do is you see the first and the last term. You see the first and the last term. F of 1 by 20 plus f of 39 upon 20. Can you see that the sum of these two values is 2? Sum of these two values is 2. So, if in case, if we have to try this question, we haven't done it before, we have to try this question. What we can do is, we know fx is equal to 5 to the power x upon 5 to the power x plus 5. We can find out f of 2 minus x, because we know that the sum of two x's over here will be 2, and whatever sum we'll get here, we'll write it in place of this, and rest of the things repeat itself, we'll get the answer. Yes? So f of 2 minus x will be equal to f of 2 minus x. This is 5 to the power 2 minus x plus 5. This is equal to 25 upon 5 to the power x divided by 25 upon 5 to the power x plus 5. Right? So this becomes f of 2 minus x becomes, this is 25 divided by 25 plus 5 into 5 to the power x. If you take 5 common from the numerator and denominator, this is 5 upon 5 plus 5 to the power x. So we can see that f of x plus f of 2 minus x, this is equal to this plus this. It will be equal to 1. It will definitely be equal to 1. Yes. So f of x plus f of 2 minus x equal to 1. That means 1 and 39 goes, 2 and 38 goes, 3 and 37 goes, right? 19, 18 and 19 will go. Nahi. Sum should be 40 numerator mein. So 19 and 21 will go. So 1 to 19 it will be 19 plus. Don't falter over here. You are taking pairs, you are overlapping the values 1 and 39, 2 and 38. Similarly, it will be 18 and 22, 19 and 21, and then you are left with 20 upon 20, that is f of 1. Okay? So you get 19 plus f of 1. If you put f of 1, this will be equal to 1 upon 2. So 19 plus 1 upon 2, this is 39 upon 2. 39 upon 2. The crux of this question was identifying that you have to find out f of 2 minus x. If you get that, you get the answer. Right? Chalo. Let's move on to the next. If a plus alpha equal to 1, b plus beta equal to 2, and a times fx plus alpha times f of 1 by x equal to bx plus beta times 1 upon x, x not equal to 0, then the value of the expression fx plus f of 1 by x upon x plus 1 upon x. So you can put 1 minus alpha, 1 minus a in place of alpha. This is a times fx plus 1 minus a times f of 1 upon x. This is equal to bx plus 2 minus b divided by x. Right? This is how it is written. Now, if I replace, okay, let it remain like that. Wait, let it remain the way it was. This is a times fx plus alpha times f of 1 upon x equal to bx plus beta upon x. You replace x by 1 upon x. This becomes a f of 1 upon x plus alpha f of x equal to b upon x plus beta x. And you add these two equations. So this plus this, fx into 1. So this is fx plus this will be f of 1 upon x is equal to bx plus beta x. This is 2x plus b plus beta will be 2 upon x. So x plus 1 upon x, if you take it in the denominator, this gives you fx plus f of 1 upon x divided by x plus 1 upon x equal to 2. This will be equal to 2. Right? Okay. Let's move on to the next. Let fx is equal to sine inverse x and gx is equal to x square minus x minus 2 divided by 2x square minus x minus 6. If g2 is equal to limit extending to 2gx, then the domain of function f of gx, composite function, domain of f of gx. Okay. So first thing first, we have to find out g2. What is g2? Limit extending to 2gx. So this is limit extending to 2 x square minus x minus 2 upon 2x square minus x minus 6. Yes, so this is limit x tending to 2. You can factorize x minus 2 into x plus 1 divided by, this is 2x square minus x minus 6. You can factorize this. This will be 2x square minus 4x plus 3x minus 6 2x into x minus 2 plus 3 into x minus 2. So this is 2x plus 3 into x minus 2. X minus 2 gets cancelled out. You get x plus 1 upon 2x plus 3. G2 is equal to limit x tending to 2, x plus 1 divided by 2x plus 3. So you get 3 upon 7. 3 upon 7. You get G2 as 3 upon 7. Now, f of gx, what will it be? This is equal to sine inverse of x square minus x minus 2 divided by 2x square minus x minus 6. You can simplify it to be sine inverse x plus 1 upon 2x plus 3, but you cannot put x equal to 2. This is reduced gx, but with the condition that x cannot be equal to 2. Right? Now, x plus 1 divided by 2x plus 3. x plus 1 divided by 2x plus 3 is less than equal to 1 and greater than equal to minus 1. I think you will be able to solve this after this. Right? X plus 1 upon 2x plus 3 less than equal to 1 and greater than equal to minus 1. First solve this and then solve this. You will get two intervals, you take the union, you get the answer. Yes or no? In fact, you will take the intersection. Both the conditions have to be satisfied simultaneously, and hence you will take the intersection of these two. I hope I am clear, beta. Try it. You will see that this is x plus 1 upon 2x plus 3 minus 2x minus 3 less than equal to 0. So this becomes minus x minus 2 upon 2x plus 3 less than equal to 0. You get x plus 2 upon 2x plus 3 greater than equal to 0. So you get minus infinity to minus 2 union minus 3 by 2 to infinity. Yes, minus infinity to minus 2 union minus 3 by 2 to infinity. This is when you solve the first part. Then the second, this will be x plus 1 plus 2x plus 3 divided by 2x plus 3 greater than equal to 0. This is 3x plus 4 upon 2x plus 3 greater than equal to 0. So this is minus infinity to minus 4 by 3. No, minus infinity to minus 3 by 2. Minus infinity to minus 3 by 2 union minus 4 by 3 to infinity. A option is satisfying only the right side, and you have to take its intersection with this. So it will be minus infinity to minus 2 union minus 4 by 3 to infinity. Yes, C option. C option will be correct. You have to take the intersection of A and this. There was no need of finding the limit. I don't know why I did that, but yes, it was evident that you don't have to take x equal to 2. So x equal to 2, what value is it giving? X equal to 2 should not be there in the answer, right? Or corresponding to x equal to 2, you are getting G2 equal to 3 by 7, which is in the range. 3 by 7 is coming out in the range of f of gx. That means x equal to 2 can be considered over there. Right? it has specified that g2 is equal to limit extending to 2 gx. So we can take x equal to 2 as well. Okay. Now, next. Suppose that a function f r to r satisfies f of x plus y is equal to fx into fy. When we have a function like this which says f of x plus y, f of x plus y is equal to fx into fy, we can take the function as a to the power x. This is a general function. Fx is equal to a to the power x. Xy belongs to R and f of 1 is equal to 3. If f of 1 is equal to 3, this implies a is equal to 3. Yes? So from here we get fx is equal to 3 to the power x. Fx is equal to 3 to the power x. Now summation fi I goes from 1 to n is equal to 363. That means you have 3 to the power 1 plus 3 to the power 2 and so on till 3 to the power n. This is equal to 363. You have to find the value of n. Yes, this is given to be a geometric progression, GP. Sum of n terms of a GP is a into r to the power n minus 1 upon r minus 1, which can be written as the first term is a, that is 3. Common ratio is again 3. So this is 3 to the power n minus 1 divided by r minus 1 will be 2. And this is given to be 363. Yes. So this becomes 3 to the power n minus 1. You can cancel out 3 with this. This is 121. 3 to the power n becomes 243. 3 to the power n becomes 243. And this is nothing but 3 to the power 5. This implies n is equal to 5. N becomes equal to 5. You will get your answer as 5. What we did was we used this result. Like if f of x plus y is equal to fx into fy, we use fx is equal to a to the power x. Similarly, if suppose you have f of xy is equal to fx plus fy, your mind goes to log x, because log of xy is equal to log x plus log y. Similarly, if you have, let's suppose f of x plus y is equal to fx plus fy, you have a linear expression like kx, y is equal to kx. So these are the things that you can generalize based on the result of f of x plus y is equal to fx into fy. We generalize that fx can be written as a to the power x. I hope this is clear to all of you. Let's move on to the next. Next question is, let f r to r be such that for all x belonging to r, 2 to the power 1 plus x plus 2 to the power 1 minus x, fx and 3 to the power x plus 3 to the power minus x are in AP. Then find the minimum value of fx. So we might have to use the AM, GM, HM inequality to find the range over here. It is given that these three quantities are in AP. That means 2 times fx. 2 times fx. This is equal to 2 to the power 1 plus x plus 2 to the power 1 minus x plus 3 to the power x plus 3 to the power minus x. 2b is equal to a plus c if a, b and c are given in AP. Now this is 2 into 2 to the power x plus 1 upon 2 to the power x plus this is 3 to the power x plus 1 upon 3 to the power x. Right? This quantity over here is greater than equal to 2, because if you multiply, their geometric mean will be equal to 1. So this divided by 2 will be greater than equal to 1. That means this is greater than equal to 2. And this happens at x equal to 0. Similarly, this quantity will also be greater than equal to 2. If you are looking to get the minimum value of fx, that means both the minimums occur at the same value of x, that is x equal to 0, you get fx minimum is equal to 4 plus 2 divided by 2, that is equal to 3. That is equal to 3. Because 2 into 2, 4, plus 2, 6, and this divided by 2, you will get the minimum value of fx to be equal to 3. Remember, we can write the minimum values of both the expressions only if they occur at the same value of x. Here, this expression was getting its least value at x equal to 0, and this was also getting its least value at x equal to 0. That is why we could take both the minimum values simultaneously. Right? Moving on. Next question. If fx plus 2 times f of 1 upon x is equal to 3x and S is a set which contains x such that fx is equal to f of minus x, then S is an empty set, contains exactly one element, exactly two elements, or it contains more than two elements. So for that, we first have to find out fx. We are given fx plus 2 times f of 1 upon x is equal to 3x. Yes, if I replace x by 1 upon x, this is 2 times fx is equal to 3 upon x. Yes, now I have to eliminate f of 1 by x. So I multiply this equation by 2 and I subtract the two equations. I'll get 4fx minus fx. This is 3 times fx. This will get cancelled out. This is equal to 6 upon x minus 3x. Right? So fx will become 6 minus 3x square divided by 3x. Fx will become 6 minus 3x square divided by 3x. Now f of minus x, what will it give me? This will be 6 minus 3x square divided by 3 times minus x. If these two quantities have to be equal, then 6 minus 3x square must be either equal to 0. See, if the numerators are same, let's suppose we can see that the numerators are same. Now either the denominator should be equal, that means 3x must be equal to minus 3x, that means x equal to 0. But x equal to 0 cannot be there. We cannot put x equal to 0 since it is given in the question also. Right? We cannot put 0 in the denominator. Now, if f of x has to be equal to f of minus x, there is a possibility that the numerators become 0. If the numerators become 0, it does not matter what the denominators are. So that means you write 6 minus 3x square is equal to 0, which implies x comes out to be equal to plus minus root 2. X comes out to be plus minus root 2. So f of root 2 will be equal to 0. F of minus root 2 will also be equal to 0. Right? So x can take values plus minus root 2. That means contains exactly two elements. Contains exactly two elements. I hope this is clear. I could not equate the two denominators since on equating we get x equal to 0 and x cannot be equal to 0. Right? Sure. Let's move on to the next question. Let f 1 to 3 to r be a function defined by fx is equal to x into greatest integer x divided by 1 plus x square, where greatest integer x denotes the greatest integer less than equal to x. Then the range of f is. So first we have to bifurcate f into two functions. F will be equal to, when x belongs to 1 to 2, this will be x upon 1 plus x square. This is when x belongs to 1 to 2. And f will be equal to 2x upon 1 plus x square when x belongs to 2 to 3. When x belongs to 2 to 3. Since in 2 to 3, greatest integer will be equal to 2. Right? Now, we have to find the range of f. If I look at this expression and I differentiate this, let's suppose I differentiate the first expression. I am using range via differentiation. Okay. So f dash for 1 to 2, this will be 1 plus x square whole square. In the numerator, it will be 1 plus x square as it is into differentiation of x, that is equal to 1, minus x as it is, differentiation of the denominator, this will be 2x. This will be 2x. So you get this as 1 minus x square upon 1 plus x square whole square. This is the derivative of the first function, that is from x equal to 1 to 2. This is 1 minus x square upon 1 plus x square whole square. The denominator is positive. You can see that. The numerator for x belonging to 1 to 2 will always be less than 0. It will always be less than 0 because x square will take values from 1 to 4. So 1 minus any value from 1 to 4, that will give you a negative value. If f dash x comes out to be less than 0, this is a decreasing function. This is a decreasing function. You can check for the second function as well. You must check for the second function as well. So if you differentiate the second function, you will get 1 plus x square whole square. In the numerator, you will get 1 plus x square into 2 minus 2x into, this will be 2x. So you get 1 minus 2x square, 1 minus 2x square divided by 1 plus x square whole square. And again, this has to be less than 0. This has to be less than 0 since x square will belong to 4 to 9. And definitely it will be less than 0. So again, it is a decreasing function. F overall is a decreasing function. Yes. So from 1 to 2, the maximum value will be at x equal to 1. Minimum value will be at x equal to 2. That means it will have the range as, when you put 1, you get 1 upon 2, open bracket, this will be the maximum value in this interval. When you put 2, this is 2 upon 5. So this is the minimum value in the interval, both open brackets. Union. When you put x belongs to like 2 to 3, it is a decreasing function. When you put x equal to 2, this will be 4 upon 5. 4 upon 5. This has to be the maximum value, right? Since it is decreasing. And when you put 3, you get 6 upon 10. 6 upon 10 is 3 upon 5. So this will be 3 upon 5. At x equal to 2, you will get a close bracket. That means 4 upon 5 will be under close brackets. Rest all will be open. So 2 by 5 to 1 by 2, union 3 by 5 to 4 by 5. I see this as option D. For x belonging to 1 to 2 also it is decreasing, and for x belonging to 2 to 3 also it is decreasing. So range will be in between 1 to 2, it will be maximum at 1, minimum at 2. And then for 2 to 3, it will be maximum at 2 and minimum at 3. So maximum at 2 is 4 by 5, minimum at 3 is 3 by 5. You answer D option. I hope this one is also clear. This was a good question. Mark it as a good question. Right? Let's move ahead. The domain of the definition of the function. I told you that when log comes into the picture, we can always solve the inequalities. We can get the domain of the function using wavy curve. So in this question, fx is equal to 1 upon 4 minus x square plus log x cube minus x base 10. And these questions are not just for practice. I want to tell you that such are the questions which come in JEE mains in one or the other attempts. So when you go to give the exam, you have to be aware of the fact that such questions come. It's not always the toughest of the problems from functions that you will see in your paper, right? So you don't have to treat functions as one chapter which you don't know. You might get a very easy question to solve, which you can solve through the very basics. So do cover your functions really well, okay? Especially the basics. You might be seeing a lot of questions from domain, from range, from getting the minimum or the maximum values, and all these are questions of functions only, and all these have been asked in the mains attempts. Yes, so don't skip these parts. So denominator 4 minus x square must not be equal to 0. That means x should not be equal to plus minus 2. Plus minus 2 should not be in your domain. Correspondingly, x cube minus x, this must be greater than 0. Should not be equal to, it should be greater than 0. Log has x greater than 0. So this is x into x square minus 1 greater than 0. This is x plus 1 into x minus 1 greater than 0. You can write it over here, minus 1, 0, 1, plus, minus, plus, minus. Now, if you are taking greater than 0, you are writing minus 1 to 0, union 1 to infinity. But there is a problem. You cannot take, minus 2 is taken care of. Minus 2 is already not in this. You have to exclude 2 from your answer. So you can write minus 1 to 0, union 1 to 2, union 2 to infinity. See, this might be in your answer. Minus 1 to 0, 1 to 2, 2 to infinity. C option. C option. Right? The base need not be worried about. It is given to be 10. So you need not check the domain for the base. But rest of the things, first is that you have to put the denominator not equal to 0, and you have to take x cube minus x greater than 0. This is your required domain. Got it? Let's move ahead. Let's move ahead to the next question. Let f r to r be defined by fx is equal to x upon 1 plus x square. Then the range of f is. Now see, I might be seeing another question like this. Let me check. See, here is one of the questions. If the function r except for 1 and minus 1 to a defined by fx is equal to x square upon 1 minus x square is surjective, then a is equal to. So what they do is, in the question before this, okay, the question that we will be solving right now, they gave r over here and asked the range. Another way of asking the range is that they give the codomain as a and give the function as an onto function. If the function is onto, then the range will be equal to the codomain, and they ask you the set A. That means they are basically asking you the range. Right? So we'll solve both questions one by one. First, we'll solve that one. I'm just telling you that you get different questions on range through different words. It means the same thing. Now, the range of f, y is equal to x upon 1 plus x square. You have to find the values of y. So what you do is, you cross multiply y plus yx square minus x is equal to 0. You get a quadratic in x. You have x square y minus x plus y is equal to 0. 1 minus 4y square must be greater than or equal to 0. Yes? So this implies that 4y square must be less than equal to 1, which implies y belongs to minus half to half. Minus half to half. Now, don't be hurried in ticking the answer. First, check that can you get half and minus half as answers? Can you get that? Please check. If you put y is equal to half, you get 1 plus x square is equal to 2x. Yes, you can get it at x equal to 1. If you put minus half, you will get minus 2x over here. You can get at x equal to minus 1. If you put minus half, y is equal to minus half will give me x square plus 2x plus 1 equal to 0. That means yes. minus 2x. If I have minus 2x over here, I'll put x equal to minus half, minus 1 and get the answer. This will give me y is equal to minus half. This will give me y is equal to half. So both the answers are included. That means yes, A option will absolutely be correct. Right? A few more solutions that you see can also give you another method of this. Like they can give you y is equal to x upon 1 plus x square can be written as 1 upon x plus 1 upon x. Y is equal to 1 upon x plus 1 upon x. Now you know that if x is greater than 0, x plus 1 upon x is greater than equal to 2. Yes. So if it is greater than equal to 2, for, you can write it over here, for x greater than 0, y is equal to 1 upon this quantity will be greater than equal to 2. So that means your maximum value is half and minimum value will be 0, because if this value goes to infinity, y will go to 0. So that means for x greater than 0, y belongs to 0 to half. 0 open and half closed. Then for x less than 0, y will be 1 upon a value which is less than equal to minus 2. It is greater than 2 or it is less than minus 2, because magnitude wise it is greater than 2. So if it is less than minus 2, then y will belong to minus 1 by 2 to 0. Minus 1 by 2 to 0. So if you take union for both the cases, x greater than 0 and x less than 0, you will get minus half to half, excluding 0. And when will you get y is equal to 0? By putting x equal to 0. So the third case will be x equal to 0 and you will get your answer as minus half to half. So this is alternate method of solving this problem. You will not get this every single time. That is why this is a full proved method. But in special occasions, like when you can directly apply this, these methods are also useful. Got it? Let's move ahead. Let's move to the next question. Let f r minus 3 to r minus 1 be defined by fx is equal to x minus 2 upon x minus 3. So they have given you the domain, they have given you the codomain. That means they want you to check that this is a 1, 1 on 2 function. Since they have excluded the range over here, the values that y cannot take, they have excluded that from the codomain. Right? Now, let gr to r be given as gx is equal to 2x minus 3. Okay. Then the sum of all the values of x for which f inverse x plus g inverse x is equal to 13 upon 2. What is f inverse x equal to? Find out f inverse x. I told you how you can find out f inverse x by either putting x is equal to gx and equating it equal to x, or you can also write x in terms of y and then exchange x and y. So what we'll do is we'll consider f of gx. This is equal to gx minus 2 upon gx minus 3. Don't take it as gx. Gx is already there in the question. Let us consider f of hx. This is hx minus 2 divided by hx minus 3. This is equal to x, where hx is the inverse of f. This becomes hx minus 2. This is x into hx minus 3x. This gives me hx equal to, it will be 3x minus 2 upon x minus 1. 3x minus 2 upon x minus 1. This is the inverse of f. Right? Then when you talk about the inverse of gx, so gx is simple. Gx plus 3 is equal to 2x, right? So you can write x as gx plus 3 divided by 2, and now you can replace x and gx. You will get g inverse x is equal to x plus 3 divided by 2. X plus 3 divided by 2. I hope this is clear, beta. G inverse x will be x plus 3 divided by 2. Now it is given f inverse x plus g inverse x is equal to 13 by 2. So what you can do is 3x minus 2 upon x minus 1. 3x minus 2 upon x minus 1 plus x plus 3 divided by 2. This is equal to 13 upon 2. This is equal to 13 upon 2. And you need the sum of all the values of x for which this is true. So what you do is you take the LCM. This is 6x minus 4 plus x square plus 3x minus x, that means plus 2x minus 3 divided by 2 times x minus 1 is equal to 13 upon 2. 2 and 2 gets cancelled out. This is x square plus 8x minus 7. This is equal to 13x minus 13. This gives me x square minus 5x plus 6 equal to 0, or you get x minus 2 into x minus 3 equal to 0. You get x equal to 2, x equal to 3. वैसे otherwise you could also see the sum of values to be equal to 5. Sum of roots, that comes out to be minus b by a. You will get the sum of values equal to 5. X equal to 2 and x equal to 3. Wait. X equal to 2 and x equal to 3. But we cannot take x equal to 3. We cannot take x equal to 3. F inverse x is defined for R except for 1, or we can take it. There is no problem in that. See, F inverse x is this. It is defined for x equal to 2 and 3 both, and G inverse x is x plus 3 upon 2. So it has nothing to do. I just thought for a while that it is given R minus 3, but that would have been considered had it been fx in the equation. Since fx is not there in the equation, it is just f inverse x plus g inverse x. Both these functions are defined for both x equal to 2 and x equal to 3. That means the sum of values will be equal to 5. Right? Okay, let's go. Next question. Let x denote the total number of 1-1 functions from a set A with 3 elements. This is set A with 3 elements, A1, A2 and A3, and a set B with 5 elements. This is B1, B2, B3, B4 and B5. Let x denote the number of 1-1 functions from A and y denote the total number of 1-1 functions from the set A to the set A cross B. Okay. First, we find out the value of x. This is the number of 1-1 functions. Number of 1-1 functions from A to B. How many will be there? We studied that when m is less than n, the number of 1-1 functions will be 5c3 into 3 factorial, or you studied 5p3, right? So this is 10 into 6, this is 60. This value is 60, right? Then total number of 1-1 functions from the set A to set A cross B. How many elements will be there in A cross B? This is A, 3 elements, and this is A cross B. This will contain 15 elements. Yes. So y will be equal to 15p3. 15p3. Right? So it will be equal to 15 into 14 into 13. You have to multiply this. I don't like it. Let's leave it to 15 into 14 into 13. Now y is this and x is equal to 60. What do we have? We have 4 relations. 2y is equal to 91x. Let us substitute in this. 2y means 30 into 14 into 13 is equal to 91 into 60. I don't like multiplying, that is the problem. This is 2, this is 7, 91 equal to 91, A option is correct. Let us check for the other options as well, had it been C or D option. See, 2y cannot be equal to 273x, that is for sure. Rest of the options won't be correct since y cannot be equal to 91x and y cannot be equal to this. A option is absolutely correct. You could have checked it from any of the options. You will get the answer. 2y is equal to 91x. Remember, this is A and this is A cross B. A cross B contains number of elements is number of elements of A into number of elements of B. That is 15. Right? Next, let us move to the next question. Let us move to the next. If gx is equal to x square plus x minus 1 and g of fx is equal to 4x square minus 10x plus 5. Gx is x square plus x minus 1. Then f of 5 by 4 is equal to, okay, put x is equal to 5 by 4 over here. Since obviously we need the value of f of 5 by 4, you can put x is equal to 5 by 4. You get g of f 5 by 4. This is equal to 4 into 25 by 16 minus 10 into 5 by 4 plus 5. So what do we get? We get 25 by 4 minus 50 by 4. So this is minus 25 by 4 plus 5. So this is minus 5 by 4. G of f of 5 by 4 is equal to minus 5 by 4. And if you put x is equal to f of 5 by 4, x is equal to f of 5 by 4, what do you get? You get minus 5 by 4 is equal to, let this equal to p. We need to find the value of p. So this will be p square plus p minus 1. Right? This implies p square plus p, you take this to the right hand side, this will be 5 by 4 minus 1 plus 1 by 4 is equal to 0. Yes? So this is nothing but p plus half whole square is equal to 0, or p will be equal to minus half. P will be equal to minus half. What is p? P is f of 5 by 4. F of 5 by 4. So it will be equal to minus half. I hope this is clear, bache. Moving on to the next. The inverse function of fx equal to 8 to the power 2x minus 8 to the power minus 2x divided by 8 to the power 2x plus 8 to the power minus 2x when x belongs to minus 1 to 1. How do we find the inverse of the function? I told you that you can express x in terms of y and then interchange x and y. So how do we reduce it into that form? That is the key. If I take 8 to the power minus 2x as 1 upon 8 to the power 2x, y can be written as 8 to the power 4x minus 1 upon 8 to the power 4x plus 1. 8 to the power 4x minus 1 upon 8 to the power 4x plus 1. Right? If I cross multiply, this is y into 8 to the power 4x plus y. This is equal to 8 to the power 4x minus 1. So I get 8 to the power 4x equal to y plus 1 upon 1 minus y. Y plus 1 upon 1 minus y. You take 8 to the power 4x, you take y into 8 to the power 4x to the right hand side, you will get this. Now take log both sides. Take log both sides. You get 4x into ln 8 is equal to ln of 1 plus y upon 1 minus y. So you get x is equal to 1 upon 4 ln of, or you can also write log. You can also write log base 8. This is 1 plus y upon 1 minus y. X is equal to 1 upon 4 log 1 plus y upon 1 minus y base 8. Right? Now you can exchange x and y. You get y is equal to 1 upon 4 log base 8 1 plus x upon 1 minus x. And this is your inverse. This is your inverse. This had to be 8. This had to be 8. There seems to be a misprint in this. D option will be correct. I don't see any of the other options which are finishing at this. I can only see that this is 1 by 4 log 1 plus x upon 1 minus x with base e. That might be a misprint. E and 8 can be sometimes mistaken. So this will be 8 over there and answer will be this only. This is the correct answer. Because when you take ln 8 in the denominator, it can be taken as log of this base 8. Right? I hope this is clear. Let's move on to the next. Let's move on to the next question. If the function f r minus 1 and 1 to a be defined by this is surjective, that means you have to again find the range of this expression. And that range will be equal to the codomain. Yes? So y is equal to x square upon 1 minus x square. You can obviously cross multiply. This becomes y minus yx square is equal to x square. You get x square is equal to y upon 1 plus y. X square is equal to y upon 1 plus y. And you know that x square has to be greater than or equal to 0. That means y upon 1 plus y has to be greater than or equal to 0. You put minus 1, 0, plus minus plus. You have to take the plus sign. That means minus infinity to minus 1 union 0 to infinity. 0 to infinity. 0 will be closed and minus 1. Can y be equal to minus 1? No. So this 0 will be with a closed bracket. Minus infinity to minus 1 union 0 to infinity. I see no option like this. So we have to write it in the other form. This becomes r except for. You have to subtract minus 1. You have to leave 0. So r minus 1 to 0. C option. Remember, you are considering 0 as your answer. So you don't have to subtract it. That means you will take it with open brackets. You don't have to take minus 1. That means you are subtracting minus 1 from the answer. So r except for minus 1 and 0. Minus 1 to 0. Sorry. Right? C option will be correct. Let's move on. Let's move on to the next. You are getting the value 0 at x equal to 0. Yeah, that's fine. That's fine. Let's move on to the next. The function fr to minus half to half defined as fx is equal to x upon 1 plus x square is. So invertible, that means 1 1 on 2. Injective but not surjective, that means 1 1 into. Right? This is 1 1 on 2. This is 1 1 into. Surjective but not injective. This is many 1 on 2. And this is neither injective nor surjective. This is many 1 into. You have these 4 options. You have to tell, considering the domain and range, the codomain in fact. So fx is equal to x upon 1 plus x square. If I consider fx1 equal to fx2, fx1 equal to fx2. So you have x1 upon 1 plus x1 square is equal to x2 upon 1 plus x2 square. Right? If I cross multiply x2 plus x1 square x2 is equal to x1 plus x2 square x1. This becomes x2 minus x1 is equal to x1 x2 into x2 minus x1. You have either x1 equal to x2 or you have x1 x2 equal to 1. That means the value that you will get at x equal to, let's suppose, 5, you will get the same value at x equal to 1 by 5 as well. So you are getting the same value for two values of x. One is according to x1 equal to x2. Had this been the only solution, it would have been a 1-1 function. But no, it is not the case, since x1 x2 is also equal to 1. So this is definitely a many-one function. Many-one function. It cannot be A, it cannot be B. It is definitely a many-one function. Now we have to see that whether its range is minus half to half or it is something else, right? So consider this as y plus yx square minus x equal to 0. We solved this question a few minutes back when we found out that y belongs to minus half to half. Do I remember it correctly? Yeah, this was the question. X upon 1 plus x square. So its range came out to be minus half to half. Minus half to half. That means the codomain is equal to range. That means it is an onto function. So many-one onto function is correct. Many-one onto function is correct. Right? It is surjective but not injective. It is a many-one onto function. यहाँ पे y belongs to minus half to half. I hope this is correct. I hope this is understood. I know it is correct. I hope this is understood. Let's move on to the next. If g is the inverse of a function and f dash x is equal to 1 upon 1 plus x to the power 5, then g dash x is equal to. It's a very common question asked in a lot of exams, various exams, state entrance exams and all. And it might come again. The probability is that high. So what happens is you have two relations. See, f of gx is equal to x and g of fx is also equal to x. Yes, you can use either of the two relations and get the answer. So if we consider this relation and I differentiate it, this is f dash gx into g dash x is equal to 1. So g dash x is equal to 1 upon f dash gx. What is f dash x equal to? F dash x is 1 upon 1 plus x to the power 5. So what will f dash gx be? F dash gx will be 1 upon 1 plus gx to the power 5. And its reciprocal will be equal to 1 plus gx to the power 5. Yes? So 1 plus gx to the power 5 is correct. D option. Let's see how can we find out using this relation. See, this is g dash fx into f dash x is equal to 1. So g dash fx will be equal to 1 upon f dash x. 1 upon f dash x. So g dash fx will be equal to, g dash fx will be equal to 1 plus x to the power 5. Now, how do we find out g dash x from this relation? We put x is equal to gx. What do you get? G dash f of gx. And what is f of gx equal to? X. So g dash x will be equal to 1 plus gx to the power 5. You get the same answer from both the relations. You can use any of these. Right? Okay. So this ends our first lecture on functions. I know there will be a lot of things that you want to ask. I will be reading the comment section very thoroughly and I'll be waiting for your comments. If there is anything that you have a problem with, just mention the topic, just mention the heading, and that will be cleared in the days to come for sure. Right? So good luck everyone. Keep studying, take care of your health, keep smiling, and see you all very soon. Bye bye.